Should we start? Hello, Simon.
Welcome everyone to our stream. It's day 2, and we're having lovely technical problems, just trying to get things together. We have 2 simultaneous streams, so you're going to see me in double vision right now if you're opening up both. Sumit, welcome to the stage. How are you doing this fine London morning?
We had an amazing day yesterday, and today is it's a bit misty out there, but I think we got so much good content.
It's an early Sunday morning. You are lucky you're getting me this early. So we're going to attempt to do 2 streams simultaneously. Please forgive our mistakes. We will get there. I'm going to stay on track 1. Timothy's going to go off to track 2, and you'll find both video links in the YouTube. We also have in the description below, and if you're watching us on Spatial Chat, hello. We're going to be having a spatial chat to one side so you can all communicate and chat to each other about the topics that the speakers are talking about. And in there, you can also watch these videos. So you don't have to have YouTube open. If you go to Spatial Chat, you can watch everything in there. Hopefully that helps. And yeah, we'll disappear because at the moment we're eating into the scheduled time. And we'll see you. We'll have some breaks, and we'll split up the day a little bit, I think. But for the most part, if you want to take a break and it's not content you don't like, go take a break. We don't expect everyone to be here for the full, 8 hours or whatever the stream's going to go for. So yeah, thank you for joining us. Sumit, did you want to say anything before we get going?
I think enjoy the day. There's a lot of good content, and hopefully we don't have any more technical glitches. So yep, fingers crossed. Go ahead.
Fingers crossed. Right, I'll see you on the other side, Sumit. So while Sumit deals with track 2, hang on, let's just see if we're going on here. I think, Sumit, you've got track 2 here, so I'll leave it to you to schedule videos and to get going there. Right, track 1, I'm here. Let's see if I can get a video going for you guys. So the first video we have is Rebecca. Rebecca is talking about Spice Flutter apps with flavor, Spicing Flutter apps with flavor. Rebecca is going to take it away, hopefully, any second if things are working.
Hello everyone, welcome to Flutter Festival of London. It's really exciting to be here. Before we start, I would like to introduce myself because you have to get to know me. My name is Rebecca Saka, and I'm a Flutter developer. And in this session, I'm going to walk you through how to create spicy Flutter apps using flavors. Exciting, right? So you might ask, what are flavors? Why do we need them?
I'm afraid her audio is really low on the video that she submitted, and I guess I didn't get to check in this one, so I'm sorry, but
Well,
Looks like you're just going to have to put up with this as it is for our first talk. Hopefully the next one is going to be better. I'll go check them now.
What are flavors? I defined it in a very simple term. Basically, well, I didn't define it, I saw it on Google. But then flavors are used to create multiple versions of the same app using the same code base. It's actually very simple. It's just like Flutter, our favorite Flutter, using we use Flutter to create the same app on different platform for the same code base. So that's just what flavors are. Flavors are used to create multiple versions of the same app using the same code base. Well, now we've gotten the definition. So now, how are they important or why are they important? There are a lot of uses for flavors. This I just highlighted two of some of the use cases of flavors. Number one is to separate builds for non-production and production environments, and the other one is to build configuration for different clients. So let's take it one by one. Separate build for non-production and production environments. Basically, during development lifecycle, we have different stages. The first stage is development, where you are busy coding, you can't eat, you're just drinking coffee, you have to stay awake, you want to make sure the app works because your boss is going to kill you. And the next one is staging, where you have finally done something and the internal testers have to test if everything is working or if you have to fix bugs. Then the next stage after staging is the production stage. You've done it. The boss is happy. Every user have access to your app and they are expecting more release from you. Now, how does these stages relate with flavors? During development, you have, as I said, you are connecting to an API and you need to test if everything is working, or even doing staging, you need to test if everything is working. So, for example, you might create different accounts, basically you are sending different things to the API. But then you don't want these things that this guy and this guy is sending to the API to be on the live production API. So this is where flavors come in. With flavors, you can create an API that this guy and this guy can use, but this guy doesn't have access to it. So using build flavors, you can set your configuration to make sure that this guy and this guy share the same API, but this guy doesn't have access to the API. Get it? The next one, which is build configuration for different clients, I would say is kind of similar to the first one. You can have, for example, a perfect example actually. When I was preparing for this session, I saw an interesting use case on a YouTube channel where the company wants to have access to different payment platform for users all around the world and a different one for users in China. So they made use of flavors. With flavors, they said, this is Mr. China, for example, and this is the rest of the world. In flavors, they said it's different payment platform for this guy and a different payment platform for this one. So basically, it's the same app, but they are sharing the same payment platform. So how do we go about it? How do we implement flavors in our app? Well, which is the next step we are going to. To implement flavors, we have to take 3 steps. It's actually more than 3 steps, but you get it. It's 3 steps. You have to create that site configuration, and you create the native site configuration and the native iOS configuration. For now, you can't just write that code and everything works. Hopefully, it would improve in future, but for now, we have to do everything manually. And to do that, let's go to VS Code. On VS Code, I have my app running. It's a basic app where you just display the app icon for the current app and the test, the welcome test. Then the development environment is going to be here when we are done. Okay, so let's get right into it. The first thing we need to do is we need to come to our main.dat file. We have to create, we have to rename this to main dot main common. You can actually use anything you want, but this works for me. And we'll come to our main file, our main function rather, and we'll also rename this to main common. So the example I'm going with the stages of development. I'm using these stages of development and how to configure it for different production environments. Going back to VS Code, we would have to create different files, which is for the different production environments. So after creating this, we would, before we continue to write codes that are going to be inside these files, we need to create a Flutter, a flavor configuration file. So basically, this is what I want to configure in my app. I want to change the app title, the build type, and the image location. So I have some images here, which I would be using. So I would want it to display different image here, depending on the build type. After creating this, we'll now go back to our main.common. We'll create a variable that called flavors config. Here we'll be collecting an argument called flavor config. We would set flavor config to config. So we'll go. Let's start with the main development. We would have to create a main function in here. So in here, we are going to define the config for the development environment. Remember, we created main common here, so we would call main common function in this case. So we call main common and we pass the config as an argument. So basically, once this main function runs, it passes the main config here and it comes here to set this flavor config as the config we are passing from the main development file. So I'm going to do the same for the other main files. So now we have our three main files set up. So we'll go back to main common. Now we have this flavor config set up, and we want to make sure that all our flavor environments share the same config based on what we set in this place. So we'll come here, this material app, we can change the title. So in my home page, I can set my app title to this. Remember, this is just a brief introduction. To do this in a standard app, you have to make sure you use your state management with it, so your code will be cleaner. This we can do. So it's going to welcome us to the build type of the current Flutter app we are in, and we are going to set our image location here. So if we run it now, it's not going to work because we do not have an entry point. So here brings us to our second stage, our second step actually, which is to set up the native Android configuration side. So let's get into it. To do that, we would go into the Android and go to app, go to build grading. Here we are using the default configuration that Flutter set for us. So we have to write our flavor dimension here. So then the next thing we'll do is, when typing this, make sure you check out for typos. It's very common to have typos there, and we know. See what I was saying? This is flavor dimension, not flavor. And set our application ID to our default config ID, and we'll just change this to .dev. You can do a lot of things here, but I'm just changing the version and the version name. With the version name, you can have a lot of things. I'm just going to put it at 1.0. So you can have it as beta or alpha or anyone you want. So I'm just going to leave it at this. So I've created the product flavor for development, but we also have for staging and production. So I'm just going to do that and get back to it. So having done this, we can run our Flutter app with F5 or whatever you're doing, because it's going to show you to set your main entry point. So to do that, luckily we have launch.json in VS Code, which you can basically define your build configuration. So this is the default build configuration. It was supposed to go to our main.dat file, but we do not have a main.dat file here. So what we'll do now is to set up the configuration for each of the production flavors. And let's do that. So with that, we have to set this configuration. Basically, we will replace the former one with this one, which would have to put the name as anything you want here, but I'm just going to leave it as dev flavor. The request launch the program, which is pointing to our main.dat file here, and the argument, which is it's the flavor, the developments which we defined here, and the target is lib.main development. So we'll do that for staging and production. After doing this, we would come to, if we come here, we can now switch our production environment here, and it would point to the different flavors that we want here. Our app is now running. This is the current development flavor. And we have welcome to dev development, and this is our icon for the developer. So it's awesome. We can also switch to staging. Now, this is the staging app. So if we minimize this and go home, we now have 3 different flavor app. So basically we have one for development, and we would also have one for staging. If we minimize it, our title, we have staging flavor and development flavor. But now the problem here is both share the same name and the same app icon, which is what we are going to do next. But before we do that, we see that the Android part is now working perfectly, but the iOS part not so perfect. So this is where we come to our third step, which is to set up the native iOS configuration. It is important to know that on Android, flavors are called build variants, while on iOS they are called schemes. So what we want to do now is we want to set up iOS schemes in Xcode. We'll open our iOS in Xcode, and we'll create new schemas. We'll name it development, and we'll do that for staging and production as well. We go to project runner, and in the build configuration, we are going to create duplicate the debug configuration and duplicate to debug development. and do the same for the other build variants we have, that is development, staging, and production. We would go to the production and go to edit schemes, and we'll have to set each of them to the build configuration we just did. Now, after creating the project in this code, we want to change the app name and the app icon, so they will have different production flavors. To do that, we would go to our Android file, go to app, inside source, we would create different folders according to our need. Inside here, we are going to create a resource folder and create a values folder. We are going to do it for the rest too. So we'll go into main, the resource folder, and go to values. We would create a new XML file called strings.xml. This is the default string.xml. I just pasted this hard coded one. It's the default one. So what we are going to do now is go into view.gradle file, go to Android manifest file, then we will do in our label, we will do string.appname. So this string.appname is referring to our string.xml that we defined here. So we have to do the same for each of these folders that so now if we stop our apps and run them again, we should have different names for our app. As we can see, our apps have different names. This is dev flavor, we have prod flavor, and we have staging flavor. How do we change the app icon? This is possible using this up package called Flutter launcher icon. To do that, we have to create different YAML file for the different build configurations. So for the first one, I'm going to do we would create each one for all. After creating this, we would have to add some configurations here. Well, as usual, I have done that for you. I'm just going to copy and paste. And by the way, I'll be releasing this code on my GitHub, so you can just go there and see the way I did it, so you can follow along. Remember, this image path is referring to our assets here. So we say dash stage.png. So that's it basically. We would come to terminal and run, and would reference it to our file here. So running this file can be anyone. Once you run this, it's going to automatically run for all your configurations here, because you are referencing it with this hyphen, you are referencing with all. Okay, so you might get this error. This basically means that you have to come down to your Android folder and go to your build.gradle, edit the minimum SDK version to 21, and you can also edit this, but it doesn't matter. Edit it to 21, and if we run it again, okay, I have to save it. If we run it again, it should work now. see it has generated for flavor staging, flavor development, and flavor production. If we go back into our source file and we go into development, we see that we now have launcher icons here. Different launcher icons. Same thing for production and staging. So for our iOS too, it's also generated it for our iOS. So one thing to know about iOS development is if you are using a transparent background, your iOS would not accept the release. So you have to use the argument remove alpha iOS and set it to true. So we'll run it again. So it will generate a new as generated. So I'll close this up and run each one again. As you can see, we now have different app icon and different name for our apps. So we have successfully generated the app icon for Android and the app name, but it has not reflected on our iOS app. To do that, we would have to go back to our project on Xcode. And go to runner, go to info.plist, create a new key and call it the bundle display name. We would set that to app display name. Now we'll go back to runner build settings and we'll go to all and we'll create a new add user defined settings and we'll call it app display name, just like we said in the previous step. Now we have to change for each of the build variants or schemes in this case. Now we have successfully changed our app name. Now to change our app icon, we'll go to runner build settings and we'll search for assets. It will bring out the app icon. Here it shows that all the schemes are using the same app icon, but we have already generated it on our asset folder using the package, the pop package that we did the other time. So now we would set each icon to the pop package we generated, and with that our iOS app now have a new icon. We have successfully launched an app with different flavor configurations. You can either launch your project using VS Code or Android Studio or S Code, launch it on Android or iOS, everything works. Well, thank you so much for staying tuned in the session, and I hope you enjoy the rest of the event. Before you go, I would like you to connect with me. You can connect with that using, you can connect with me using this Linktree link. Just type in Rebecca Saka and you can have access to all my links. You can also have access to this slide, the link to this slide, and the link to the GitHub repository. Or you can just search for my name on GitHub using Becca_Saka and Twitter using Bex. Please note this is _, and on LinkedIn you can just connect with me using Rebecca Saka. Thank you so much and enjoy the rest of the session. Remember to add spice to your app.
That was really good, Becca, actually. So adding spice to your app, I like that. So our next speaker is I can't say his name. This is our next speaker, Mota. I'm going to go with that for now. And he's from Bitrise, and he'll be talking about tips to optimize your Flutter app for deployments. So take it away.
Hi, everyone, and welcome. Thanks for having me today at Flutter Festival London. My name is Mu'taz Nabil. I'm a developer advocate at Bitrise, and today I will be talking about tips to optimize Flutter app deployment. So today we'll be talking about challenges that we are facing when releasing or deploying Flutter apps. Especially we have two different apps, iOS and Android, inside the Flutter application. So we are publishing to two different app stores with different configurations and requirements. So today we have different tips, and we will start discussing them in the next slides. So at the beginning, a little bit information about me. I started my career as a .NET developer. I was working with a .NET stack, and then I switched to be a test automation engineer. And during my career, I working with different business domains like agriculture, telecom, healthcare, fashion, and food delivery. I participated in design and creating and design and create a lot of test automation frameworks using a different set of tools and technologies for web and mobile and API as well. And currently I'm focusing on implementing different CI/CD pipelines, especially for mobile apps, to help mobile developers to accelerate their builds and their releasing and deploying. So as we know, Flutter is like a cross-platform UI kit or SDK that's designed to allow code reuse across operating systems such as iOS and Android. So the idea from the beginning was like one code base, you can develop two separate or two native applications, which is for iOS and Android. And now we have, or like Flutter now supports web and Windows as well. So this is the main idea. So the goal is to enable developers to deliver high-performance app and also easily to develop two different native applications with the same code base. So the main idea behind Flutter is to enhance the performance and the speed and the stability of the application. But actually, we have different challenges when we are building or when we are like creating or releasing our mobile apps, especially when we are dealing with a CI server or continuous integration servers, or when we are trying to applying the continuous integration and the continuous delivery or continuous deployment concept or approach. So here we have a challenges. So from almost 1 week ago, I asked my connections on LinkedIn about, as a Flutter developer, what is your Flutter CI/CD pain point? So what is the main problem, or what is the biggest problem you are facing on your day-to-day activities, or when you are developing or start releasing your Flutter app? And the answer was iOS code signing, which is we already know as iOS developers as well, which is a code signing for iOS is a big deal and it's a big headache, and it's taking time to trying to automate it, or even if we are doing it manually, it's a hard process or a painful process. But actually we are or we have different challenges as well. We have a difficult setup, we have a speed and stability for the CI and CD pipeline or the CI server in general, ease of publishing, how we can deploy our applications in the app stores, because we have, as we mentioned, different app stores, how we can publish our apps like straightforward and with one process and without any complicated steps. Because that, I believe that most of the challenges we have is inflexible and fragile, or inflexible configuration and the fragile CI server, which is affecting our productivity as well. Because actually, once we are like developing the app, we need to build the application, run the unit test, run UI test, assign the application, upload it to the beta testers or beta users, deploy it to the app store, and so on, and monitoring and so on. So all of these steps, it's including in the CI server, or it's a go through the CI server or via the CI server. So the first problem is we have inflexible and fragile CI. Second one is we are releasing new features every 2 months, which is why? Because the CI process, or like releasing the process is or shaping code is a painful process, because the first point, we have inflexible and fragile CI server or different configuration. So we waste a lot of time and effort to trying to like stabilize our CI server to be able to release our features or our application more faster. So releasing a new feature every 2 months is not a good point, because if we have like different competitors in the market and they are releasing their features quicker than us, so this will be a big problem for us. So releasing features every 2 months is a big problem, and we we are trying to reduce this time to be 1 month or even 2 weeks, or can be 1 week if we have a stable process and CI server as well. So shipping code is a beautiful process, and actually we have testing in our team, but it's time consuming and required a lot of effort. So you can imagine you are testing two apps, iOS and Android, which is if you are doing it manually, it's time consuming from your QA team or QA engineers, and also it's effort as well. And I believe that you will not be able to cover all the scenario that required to relating these applications. So this is, or these are mainly the challenges that we are facing with the like, or when we are facing, when we're trying to like releasing our mobile or especially our Flutter application. Another point that let's take a look about what is a Flutter app release cycle. So this is mainly for any mobile apps, but because today we are talking about Flutter, so we are focusing on the Flutter app because here we have two different apps and two different app stores. So once we decide to start the release, we will go through the build and the test process or different steps, which is including the run unit test, increment the build number and the version, create the release candidate build, and upload the RC build as well to be distributed to the QA engineers or our beta testing or our beta testers, and doing the regression test as well. And if we found any bug in this release, so we will start from the beginning. We will fix these bugs as soon as possible, and then start the build and test cycle from the beginning. And also we are setting the approvers, which is the release managers, the stakeholders as well. And in additional or in the main meanwhile, we are creating another release or another workflow or another pipeline to start creating or preparing the metadata for the next release, including the release notes, screenshots, with everything related to the app stores, to be able to submit the apps to the app stores. So let's assume that we don't have bugs. I mean, even we don't have, at least we don't have a critical or blocker issues or bugs. So we can release or we can like submit our apps to the App Store. So the final build will be submitted to the App Store, and the approval as well will approve this. And then the build is approved and the release or the apps released to the different App Stores. So this is mainly the life cycle for releasing a Flutter application. So you can imagine if you have a stable, again, if you think again about our challenges, if you have inflexible and fragile CI and configuration and you are wasting a lot of time, even if this like you can find it as a simple steps, but in behind the scenes, it's including a lot of configurations and doing a UI test, unit test, integration, code analysis, and a lot of things behind all of these processes. So release cycle here is complicated, but it can be simple when we are like moving or start using a stable CI and CI/CD server as well. So here is a Flutter CI/CD workflow. As I mentioned, this was like the workflow from the process itself, but here what mainly we need to release the application to the App Store. So for example, the check out the repository or clone the repository or the code base, build the app for test, the lint, run linting, static analysis tool for Flutter, run unit test, UI test for iOS, Android, and the Flutter as well, including a unit, widgets, and integration test. Then we need to sign the applications. We need to like using the provisioning profile and start doing a configuration or things that required for the App Store. Releasing it, maybe we can release to the Firebase app distribution, which is maybe we can use it for the beta testers or beta users. Then after that, we can deploy it or roll out the deployment to the App Store or the Google Play Store. And then maybe we can add one step in our workflow. This is a Flutter workflow. Maybe we can add one step for publishing the test result to the development team or the responsible team. And also maybe we can send a Slack messages that including the status of the apps, maybe the link for the beta testers, the link for the beta version to our QA engineers, or even we can like publish any report or any test reports to the Slack channel. So this part is a continuous integration. So until we build and test and run all kind of tests, this is a continuous integration. Every time we are cloning, build the app, lint test, and everything. And this is once we everything is green here, we can start like doing the continuous delivery and the continuous deployment. for signing the app, releasing it to the beta channel, or releasing it to the live channel, and so on. So because all of these things and the challenges and everything, we need to think about how we can optimize the Flutter deployment. So how we can find solutions to accelerate our deployments, how we can find solutions to like tackle all of these challenges. So let's start and talking about different points and different tips to optimize these deployments. First one is, personally, I recommend to think about moving it to mobile focused CI/CD. So if you have a dedicated or in-house CI server, you are wasting a lot of time as a mobile team. You are wasting a lot of time for fixing the issues if you have inflexible and fragile CI, as I mentioned. So usually you are escalating this to the DevOps team. DevOps team is taking time to fix this problems, which is, and now you are stuck in the development. You can't release apps, which is taking a long time, and so on. So it's like a dilemma and like a lot of hassle. So you don't need to like to think about this anymore, and you need to think about moving into cloud and focus mobile CI/CD. So releasing a Flutter app, as we know, is a complex process for your team, because we, as we mentioned, we releasing two different apps. So because that, having an easy to use and stable CI in place can help to automate the development process, save the time, and make your teams deliver applications more consistently to the app stores. Your team will focus more on features, on how to enhance the app itself, the app performance, and everything inside the app or the features for your customers. But you don't need to think about anything related to the CI and everything if you have a stable and the cloud and the mobile focus CI. So a mobile focus CI tool consider the unique challenge for building a mobile apps, and has a mobile first features that help you to build your Flutter and deploy, build, test, and deploy your Flutter apps to the App Store faster with good quality as well. So this drives us to a concept of a mobile CI/CD as a service. So as we know, there is different cloud computing models or approaches, like platform as a service, infrastructure as a service, and software as a service. So here we have a mobile CI/CD as a service, which will help you to like manage the source code management, artifact management. CI/CD pipeline will help you to design different workflows and pipelines for your team. And also you have like a unit and integration and test. You can run your different automated tests inside the pipelines, automate the app deployment, which is including the code signing, the certificates, and everything required to our app store. It's responsible for the infrastructure, so you don't need to think about any hardware to maintain, which is totally on cloud, and it's managed service, which is you don't need to think about any of these hardware issues or maintenance. How does it work? So developers can automate the process that's required for building and testing and deploying a Flutter application. So for example, here we have a workflow or we have a pipeline. We are designing, we are rearranging, we are adding or removing steps from our pipeline just in visualized way. So you can add everything that required for your application to be able to release it faster to the App Store. So this is mainly how can you design workflow, and if you are working with a cloud a mobile platform such as Bitrise, for example. So here you have a workflow editor. You can start like designing your workflow, and just as you save, you can run your first build, and it will take care of everything like Flutter install, Flutter test, and like caching the dependencies and everything else. So this is mainly how the cloud or mobile cloud CI/CD works. The second point, no hardware to maintain. So as we mentioned, it's a mobile, it's a cloud, which is everything is hosted on cloud. So when automated process is triggered, so Bitrise, for example, create a new virtual machine, and you can specify, I need to run this stack on macOS or Linux infrastructure, ensuring every time is a clean environment and consistent outcomes as well. So here you have a choice in the workflow editor to change the stack between the Xcode or Linux machine, but actually for Flutter, you need Xcode to be able to build the iOS application and using or running it just for iOS and code signing and everything related to iOS. So here, there is no any hardware to maintain. You're just using a cloud hosted machines, and every time it will be clean and like a new environment from scratch. Second point, once we decide that, okay, we fix the problem with the CI, but still our application, every time we are building and catching or fetching all the dependencies from the beginning or from a scratch and building the app, everything. So, and even if you have, for example, for iOS, you are using CocoaBots, so which is taking time to, every time you are fetching and installing all the dependencies. So the second tip, which is like cache app dependencies, which is a mobile CI/CD pipeline. As I mentioned, a new build will typically execute a new environment variable or new virtual machine, sorry. So new VMs must be set up from scratch every single time, which is well downloading or fetching dependencies every time to run your build, which is waste a lot of time as well. So at the end, it will affect the build or the like the workflow time or the build time, because that with caching or like caching the app dependency, you can store and reuse dependencies between the different builds or different workflows, such as you have a Dart cache, you have Gradle cache, and CocoaBots cache for iOS during the build to speed up your workflow. So for example, here you can have different steps for pull and push cache between the different builds, and also you can save the cache on S3 bucket, on AWS S3 bucket, and also with the push and pull. So you can push after the first build, and then after that you can pull this dependencies and start like reuse this dependencies from the cache. So this is the second point. So the first one, moving it to cloud and a mobile focus CI/CD. Second one is cache the app dependencies. Third point is implement test automation, which is I highly recommend, which is highly recommended to use it with a Flutter and even with mobile testing. So here, as we know, test automation is a vital part of mobile DevOps in general, or the CI/CD pipeline. So to be able to complete the life cycle of developing or from developing to deploying applications to the App Store, you should automate the critical and the critical buses and the critical test cases, critical scenarios, critical functions with the test automation to make sure that when you are releasing, you don't have any bottlenecks, don't have any like crash or any problem in your releases. So test automation is a vital part. Testing is a whole team approach. So mobile developers or Flutter developers should start writing UI test or even integration or widgets or unit test with the test engineers or QA engineers. We should think about this strategy and plan for our mobile apps and start automating, as I mentioned, unit, widget, and integration test for our Flutter application. You can have a different and a variety of test steps like Flutter test. You can run your test on different cloud providers such as Geolocation, Source Lab, testing boot, browser stack, all of the cloud testing device. If you are using a native tool such as Espresso for Android and XUI test for iOS, or even if you are using a Flutter test, which is for unit and widget and integration, which is also required simulators, emulators to be in the CI/CD server. And this is actually another point, and it's another challenge we didn't mention, is that sometimes the flakiness of the emulators and simulators affect you as well to run the unit, the UI test. So this also related to the fragile and flakiness in the configuration of the CI server. Then after that, the next point is automate deployment, which is I need to find a way to automate or managing the iOS code signing, deploy to the App Store, to like a beta channel or to our beta testers, for example. So you can automate the process of submitting updates such as code signing, profile provisioning, versioning, packaging, release binaries, metadata, or screenshots, as we mentioned in the workflow. So here, for example, we can have a step for Xcode archive and export to the iOS, and here you can like change the method to like sign this one. For example, I need to select the distribution profile. I need to like change the options, configuration. Everything is managed, and everything is just as a configuration. And just as you can automatic the code signing using the API, using the Apple ID, or as you want. It's always a configurable step. And here also you can manage iOS code signing. So we have different steps. So you can choose between them to be able to deploy to the App Store. So with code sign step, you can easily add it to your workflow to automate signing and deployment of Flutter apps, especially this is one for iOS application, because as we mentioned, as we know, Flutter is including iOS application. Then after that, once we have a stable CI, we move it to cloud. We start using test automation, but also we start using a cache for the dependencies, but still we need to optimize the build time as well. So here, another option that we can run build in parallel on multiple VMs at the same time. So for example, as a project expands and when your team is scaling or growing, or the application or the project become more complexible or more complex, so we don't so now we do require for from the build process tons of test build steps and the setup tasks. So the app is increasing the size complexity of the process, so we need to find a way to how we can like reduce the build time again, or the workflow time, or the CI build time. So long build process slow down the development life cycle, as a developers must wait to build pipelines to complete however long it takes before verifying that everything works fine for creating a pull request. So once the developer create a pull request, we are running different checks or different steps, as we mentioned in the workflow. And if we have a lot of or like a complex steps, this will take time, which is like the developers will be stuck again and wait the build to be finished. So this is another option that we can run the build in parallel on different VMs. So for example, here you can have a primary workflow, and then you can have two sub workflows, one for iOS and one for Android. For sure, you can have all the steps for iOS and Android for everything in one workflow, but this for reducing the build time. So you can run different workflows at the same time using the parallel build. So here in the primary, you have a start build time, which is you can add this step here, and then you can specify the workflow to be triggered. Once we build and install everything related to a Flutter, then you can start in parallel running the Android CI and iOS CI in parallel. So every or each workflow will start running a different steps for iOS and Android. At the end, you will have different artifacts you can then collect again and share it with the primary workflow and continue like in the rest of the steps. So this is another steps for run multiple VMs or run multiple builds at the same time. The next point is a feature flags or feature toggle. So we can release without risk. Feature toggle, what the main idea behind feature toggle? So a feature flag is a software development process used to enable or disable functionality remotely without deploying code. Let's say, for example, we start applying a new feature in our application, which is, for example, in-app purchase, or we are adding a new payment method, for example, Apple Pay or Google Pay. We already deploying this feature or developing this feature, sorry, and we are aiming to deploy this feature. Even if we have a test automation and cover all the critical test cases, we have or we run a lot of tests and we have different type of test cases, but still it's risky to deploy this feature to the production or to the app store. So the idea is we can have a feature flag. So a new feature can be deployed without making them visible to users. And then you can start to enable or disable these features to a specific or target group of people and start like testing the features, start rolling out this feature, start A/B testing it, for example, using feature flags, which is help you to like check the feature, how does it work in the production. If there is any problem, you can just roll out, or you can just like disable or enable this feature on fly, which is like a remote configuration. You can deploy your applications, a new feature to production in small batches, which is like very useful for like releasing new features, but without, or at least we reduce the risk. So for example, here we have a new feature and we have a feature or like a group of customers. So we will enable this feature flag to this customers, and then we will disable this feature to the other customers group. So then after that, we can start to enable this feature to this group of people, and then we can enable it, or we can disable this as well to this customer if we found any problem in this feature. So feature flags, you can use it with, for example, Firebase remote config. You can use it in Flutter dependency, or you can add it in Flutter. You can use it with a Firebase. There is different cloud or different like solutions for feature flags for your Flutter application, or even for your mobile application. Applying the mobile release train, which is a process to handle or like to make it or make the release more like sustainable and like in a scheduled builds or like scheduled releases, so which is a mobile release train. So for example, here during the development phase, your team having a time to review, test, and merge features to the main branch. That should be part of the train. And also our target usually is keep master or the main branch always green. So once we have like a branch, it's already including a new feature. So we will not deploy this feature until it's tested, reviewed, merged, and everything is green to the master. And then from the master, we will start creating the release branch, for example. Then when the content of the release is agreed and ready, once we collected different features from different branch or branches from different teams, there will be a final testing phase and like end-to-end testing or like ad hoc testing to test everything is okay or run all the critical scenarios in our test suite. So the release train is we plan features and the bug fixes, for example, as a team, and then implemented the features with feature flag, because that we mentioned feature flags. So we implemented features behind feature flags with disable and enable mechanism. And then we're trying to like release this feature. Once, or like, for example, here, if the feature boarded to the release train, if it's already merged or reviewed or tested, everything is like a definition of done if we are working with Agile or Scrum. So if the feature is tested, like reviewed and everything is okay, so it can be featured to the release train. So for example, every 2 weeks or every 1 month, we have a specific day for the releases. If the feature is not ready for this date, okay, no worries. It will be like if it's ready, it will be released to the App Store. It will go to the release train. It will be released to the App Store. But if it's not not ready for this specific date, so feature misses the release train, there is no problem. It will be planned for the next release, and then it will go to again to the next release. And we have a train, something like actually the train that we are usually using. So we have a scheduled time, we have a scheduled dates, and if the features are ready to be released, it can be go to this release or next release. If not, so it can be to the next one and so on. So this is how we can like working with the release train. How we can implement the release train, adopt a fixed release train schedule, which is like can be 1 week, 2 weeks, 1 month, 2 months. So it's based on the team and how we are usually releasing our application. Identify release manager, and also you can release manager and introduce feature flags for increase the release confidence and stage rolled out. As we mentioned, feature flags is very important and help us to release without risks, and iterate and improve the development and just set up a process. As we mentioned, it's about a process between the team. We agreed together to do something about this process. So at the beginning, we talk about a few of tips to optimize the deployment for our Flutter applications, including move to cloud and using cache dependencies, and start using test automation, feature flags and release train, and also we can use also a monitor solution for your application. You can for crashes, for example, you can always check after the release what the behavior of the application, if there is any problem. So monitoring also as well with, for example, with Firebase, Crashlytics, or any other tool, you can start monitor your application. So the lesson learned here that with a suitable CI, you can automate the deployment and development process, save time, and ensure your team deliver applications more consistently to the App Store. This is the main important in our talk today, the main important point today. And then CI/CD is a coordination process. So once we have a process, we need to agree as a team to use this process, and this will be a coordination process for our team. Test automation is a vital part of mobile DevOps for unit integration, widgets, or end-to-end testing. And also testing is a whole team approach. It's a shared responsibility. It's not only responsibility for the QA engineer or the test engineers, it's a whole team. So the developers should start writing UI tests or end-to-end tests. The product owners or managers should know what the importance of the test automation, and it's a team approach or the whole team approach. So at the end, I hope that these tips will help you to like release your Flutter apps faster with a good quality. So we are focusing on how we can speed up, or we focused on how we can speed up the release cycles, how we can think about different solutions. As we know, it's like ongoing process. It's always continuous improvement. So from continuous integration, continuous delivery, continuous deployment to continuous monitoring, and still also we have a continuous improvement for our process. It's like a journey, not a destination, as we know. So it's not like one deal shot. It's always something we need to improve about. Every day we have a new challenge, and we need always to tackle these challenges. Thank you, and I hope that the talk was useful for you, and have a nice day.
Thank you. Right, that was awesome. Actually, that's really interesting. So I'm gonna say our speakers are going to be joining us, but throughout the day, based on their times, and hopefully, and they'll be able to join in the spatial chat and chat to everyone, hopefully, about their topics. In the meantime, we're running a little bit behind on the track one schedule, so I'm going to crack straight on with Carlo's talk, Carlo Lucia, and he is actually running his Hat Droid, and he runs the Flutter Italia meetup. So hopefully, take it away.
Hi everyone, and welcome. Thanks for having me today at Flutter.
Hello everyone, and welcome to Flutter Festival London. I'm Carlo, Flutter and Dart Google developer expert and full-time Flutter developer for Pivotal Technology. Today I want to talk to you about state management. In particular, I want to talk to you about Bloc. So every time we have an application, we have to somehow manage its state. We can have several types of states, because we can have a state called ephemeral, that is the most changeful state. Basically, it will change every time our UI rebuilds, and an upstate that is something more stable, for example, the cart in a shopping application. Let's see what is the difference between the two states. So, the ephemeral state, as I said, is something that can be destroyed at any time. It should represent our current state of the UI, and it should be destroyable at any moment. Usually, the ephemeral state is something that can be contained in a single widget. For example, the pressed, not pressed state of a button. When we press a button, we want maybe to get some animation. And this kind of state has no need to be stored somewhere, and also no need to be serialized, because it's something that leaves only the time needed for the UI to rebuild. The common ephemeral state that everyone knows is the stateful widget. Basically, it's the most simple way of maintaining an ephemeral state. Every time we call the set state, our application rebuild, our widget will rebuild, and its state will change. This is mostly what everyone coming from Flutter knows, because it's the most simple way to manage a state. But when we go more in depth, we may need to maintain also an upstate. The upstate is what should contain the information of our application. It needs to be stored, and sometimes it's also need to get shared across instance of the application. For example, my user information, it's a part of my upstate. If I change my username in my application, I may be able to have the same state saved even if I log in from another instance of the same application. For example, we have also the shopping cart in an e-commerce app, because when I add some item to the cart, I may want to store that information in a stable way to be able to access it from another browser or from another device. And also, it can be in an article app if I want to maintain what articles we already read or not. why you should choose Bloc as your state management. I personally choose Bloc because I found it simple and easy to understand. We have a lot of state management that can be used, but in my opinion, Bloc is one of the simplest and more immediate to grasp. It's also scalable because we can use Bloc even for a single widget, but maybe it's not where it shine more, but it's scalable enough to use it for a big and complex application. It is predictable because every time we launch a new event, we get a new state and our UI can act accordingly. And also it comes with a suite that make it highly testable. So this is how Bloc manage is interface. Basically, we have a block that is our component that manage the state, that send states to the UI and receive event to change its state. We will see only the left part of this graph for this talk. Before starting speaking about Bloc, we need to understand what are streams. Streams are a method that basically is defined with the async asterisk keyword and let us to retrieve a stream of value. A stream of value is basically a list enable that we can list. Every time we use the keyword yield, we get a new emit from the stream. In this case, for example, I had a method that it just yield a new value every time we have a new integer in our for. We can use these, for example, to create a simple countdown. I use my stream, where in my stream I yield the current value based on the value I passed in the method. For example, if I pass 10, I will yield 10, then 9, then 8, and I added an await of 1 second. Since we are inside an async method, we can use the keyword await to let our interface, our method, wait for the duration we specify. And then I can simply use that inside a stream builder, that is a widget in the basic Flutter UI library that give us a way to simply rebuild itself using the builder every time we receive a new value from the stream. In this case, I will have, since I'm passing my method with 10 as a parameter, I will simply have a text that each second will decrease from 10 to 0. This is how we pass the stream in our stream builder, basically in the parameter, and then the text will simply rebuild every time the snapshot will change. Let's see how Bloc can help us to use the streams to manage our UI. Basically, as I said, our Bloc class will accept event as input and will yield new state every time we change. For example, our counter block can be a simple class like this. The first parameter of the generic will be can be anything. It will be our events accepted by our block. In this case, I created a class called counter event, and I will show you why after I used this custom class. In this case, what we have as an event will be a parameter of our map event to state method. These will be useful to manage what we want to do when we receive an event. The second parameter is the state that we will return. It can be anything. It should be passed as a value in the super of Bloc class, and it will be the return of our stream inside the map event to state. In this case, since I wanted to create a counter, I used the int as a value, and in this case, the map event to state will return a stream of int. Then let's see how we can manage the event to communicate with the block. As I said, event can be any kind of class, and it needs to be added to our block instance to trigger a change. I created the counter event because by creating a basic class, I can then extend our class in order to define several things that our event can handle. For example, our counter event may have an increment counter extension or a decrement counter. And in our map event to state, since we need to receive always the same type of event, we can use these and leverage these to check which kind of event we sent. So our counter block will always accept counter events and only counter events. But since we are extending that, we can check if the event is an increment or a decrement and act accordingly. This is the case for increment counter, for example, and then we will have our state. The state is also any class. I used the int in the sample for simplicity, but we can have a custom class here too. And it will yield when the block notice any change. In the previous sample, we saw that the counter event was what we used in the event sending, but in this case, we will check the second parameters of the generic of the block. We are using int. As I said before, the same will be used as an initial value and will be returned inside the map event to state as a stream. Then what we need to do is to check the current state and change accordingly. For the increment counter, we will yield the new state, basically by adding 1 to the previous state. And in the decrement counter, we will subtract 1 to the state. And then let's see how we can use the UI component provided by the Bloc library in order to modify our UI. We have several concepts we have to grasp because the Bloc library is divided in several components. Some provide the ability to build a new widget, or something else will only react to the stream to the state change. For building our widget, we can simply use the block builder. The block builder is a widget that have as a generic the value of the block and the stream of return. In this case, we are using the counter block that returned a stream of int, so we define it like you see on the slide. And then it provides a builder method where we have the context and the new state emitted. For our sample of the counter, in this case, we just interpolate a string with our state, since it will be an int, and we are good to go. Sometime we might need to listen without rebuild anything. One common example can be a connection state. For example, we want to know if our user is logged in or logged out, maybe just to show a snack bar to communicate with the user. For example, you are now offline, you are now online. In this case, I created a fake connection block that will have a stream of Boolean, and I will have 2 parameters this time. Our content will be in the child parameter. This time, instead of rebuilding the content, our child will not rebuild anytime our block will emit a new state. But this content will stay the same even if we have a new event on this block listener. And the listener. The listener will be fired every time the new state is emitted. Basically, every time our block emit a new state, we will have a callback here to do what we need. In this case, for example, I'm simply showing a snack bar with the text. The connection is new state, is online, so write online or offline by interpolating a string again. Sometimes we need to use both. How we can do that? In order to combine both the block builder and the block listener, we can, of course, do the following. Basically, nesting a block listener and inside as a child, nesting a block builder. This can be done, but we have a better way to do that. Instead of using the nesting block builder inside the block listener, we can simply use a block consumer. The block consumer is basically a widget that combine the block listener and the block builder and give us a listener callback, as we saw in the block listener with the new state emitted when the new state is emitted from the block, and a block builder that will rebuild our widget when the new state is emitted. This way, we don't need to nest the two widgets, but we can use only one. Mostly, it's the same because inside the block consumer will do what we did before, but it's syntactically more simple, and we don't clog too much our code with nesting too much widget one inside the others. And we may want to optimize this because, for example, we don't want to have our build widget be rebuilded every time it change. One example I can tell you is for the battery level. For example, we may have an icon that only update every time the battery level is under a certain threshold. So how we can optimize our code in order to react only when we want? We have two ways. The bad way is to use the block to emit the state only when we need that. But since it can be used in several parts of the code, we have a better way. We can use the build when and the listen when. Either our block builder or block listener have a parameter build when or list when, and this is basically a function that should return Boolean, and it have as a parameter previous and current value. In our case of the icon, we can check if the previous event was more than our threshold and now is less than our threshold, we can trigger the rebuild. The same for the listener. For example, if we have several things, maybe we are listening to our user can have more than one information, the name, the last name, the online status or not, and we want just to listen when in our user, since we are emitting the whole user in the state, when the online status changed, and act accordingly. We can use in the list when in order to react only to state change. And of course, the block consumer has both. We have a listen when and a build when. None of those is mandatory. We can either include one or the other, and the application will react accordingly. Another important thing is how we provide our blocks. Since now we saw that our widget can listen to a block, but this block needs to be placed somewhere. The most basic way is also the one it's never really used, is to provide directly our block instance to our widget. In this case, for example, our block builder, we will add the counter block as a block parameter, and we will have our widget reacting to this single block. This can be used, may have some use for simple widget, for example, to just handle the present state of this button, but it will be limited because this parameter will be only listed from this block builder and its children. Since we may want to create our block to be able to provide the state to several widgets, we can use the block provider. The block provider is a widget that basically has two parameters. our create, where we define the initial state of the block. So in this case, we just provide the counter block instance like we did in the block builder, and our children. What happened in this case? In this case, every child of our counter widget, we will be able to listen to the block provider change. We need to understand where we want to add our block provider, because the more higher in the tree, even over our material application, the more widget will have the visibility of this block provider. And how can we send the event to the block? In order to send the event to the block, basically, we need to get the instance of the block. This will emit a state, then reach the UI, and from the UI, we can trigger the event to change the block. In this case, we need to understand how we can reach our instance of the block. As I said before, when we create a block, when we provide a block, for example, with a block provider, all the widget under the said block will have visibility about the block. In this case, for example, if we provided a block over our widget on the right, all the child will be able to interact with it. The child on another branch, or even the parent, won't be able to interact with it. To do so, we will simply use the block provider of method to get the instance of the nearest block of the generic we pass, and we can use the method add. What's happening in this case? Let's have the example of the button. We have our block builder. Inside the block builder, we have an elevated button, and we press the button. By pressing the button, we will trigger the block provider of counter block context, add increment event. What's happening here? Basically, by using the inherited widget, our elevated button will search with the off method the first instance of counter block that we'll find upper on the tree, and then we'll add the event in the counter block. Then the map event to state will yield the new state, and the new state will be propagated to all the children, included the elevated button. This basically will let us to have a button, everything under the counter block, and we will be able to communicate with the parent counter block to send event and receive the new state. Of course, as a previous example, we don't have the ability to communicate with a parent branch where the counter block doesn't exist, because everything will be in an inherited widget way of communicating. So if we need the counter block to be visible to both the right and the left part, we need to move our counter block over our parent widget in this case. Let's see some common pitfall that we can have during the use of the block library. The most important is when the block builder listener is not a child of the correct block. In this case, we will simply get an exception, because when we put a block builder and we define the type as a counter block, for example, if we are on the left part of our widgets, we will simply have an error that says no instance of counter block on this tree, because we don't have that information. So any widget put inside any block builder or listener put inside the left part of this graph that refer to counter block will simply fail its building, because it doesn't have the correct information about that. Another common pitfall is that the block will never yield its state twice. Basically, in this example, it was easy to don't mistake it, because if we have an int and we increment it, it will be surely different. But if we have a complex widget, it's not always this immediate to see. We need to implement the quality check, because normally we don't have a difference between two instances of the user if something changed inside. We can use some package like Equatable in order to define our custom Equatable check, in order to have a way to differentiate that. For example, by adding props, I want to check the quality by ID, I want to check the quality by name, and so on. And also, what we can do is to check the list, because if we change some element on a list, but we don't change the whole list, the quality check will tell you that is the same list. For example, I have two instances of a list of strings. I have one instance, sorry. I add an element to the same list. The previous and after list will be the same. If I want to add and have a difference, I have to recreate a new list and add the value, or use the deep equal method of the collection. And the last common pitfall that we have while using Bloc, if we use nested blocks, the widget will see only the nearest block instance. Let's go back to this sample. Imagine that I have another counter block over the parent widget. The widgets in green will see only the counter block we see here in blue, and will not have visibility about the parent counter block. Because since we are using the inherited widget inside, it will go up into the tree until it meet the first instance of counter block. In the same example, the widget on the left will be able to see the counter block on top of parent widget. What can happen in this case if we don't manage it properly? That every change made from the right won't propagate over to the parent widget and to the left part of this graph. And at the same way, the event sent from the left part of this graph won't reach the right part of this graph. So we need to understand that when we use a block, we can nest them, but we lose visibility on what's on the top. So that was all my common pitfall that I usually encounter when I deal with Bloc. And what I have to say is thank you for listening to my talk. And if you want to find me, you can find me as a Hatroid on Twitter. If you have any question about this talk, please write the question to me and I will try to answer. Thank you.
Thank you, Carlo. Lucia, I think I'm pronouncing that right. Hadron himself. So we're going to crack straight on because I think we're 3 minutes over schedule right now. So I'm going to introduce Sage Marcos. Marcos is going to be talking about layering your Flutter Android, layering your Flutter app architecture. So take it away, Marcos.
Hi everyone, my name is Marcos Sevilla, and this is Layering Your Flutter App Architecture. A bit about myself. I'm an engineer at Very Good Ventures, also working on open source when I have time to spare for popular packages like the Bloc library or the Very Good CLI. Also, I organize my local GDD and founded the Flutter meetup at Nicaragua. These are some things you should know about to understand this talk more clearly. First, state management in general, but state management with the Bloc library is preferred. Some kind of experience with networking or local APIs, and also understanding about basic concepts of clean code and clean architecture. Okay, so let's start with the basics. What is app architecture? It's a logical way we organize our projects. How we structure folders and files in a comprehensible way matters a lot when we have a large team that we want to follow standards. And it also makes it easy to identify the components that we need to develop a feature for our codebase. Now that we know what is architecture, let's define layers. Layers are the components that compose your architecture. We can define those by assigning a specific responsibility to them, and we should keep these layers simple yet isolated enough to achieve a maintainable codebase. Okay, so let's talk about single responsibility principle. Single responsibility is one of the solid principles from object-oriented design, and to sum it up, it tells us to, first of all, have smaller and simpler classes that have a unique purpose. Also, to better isolate components for testing. We don't have to mock a lot of stuff to test a specific functionality. And also, the single responsibility principle tells us to maintain specific functionality without affecting other. So by decoupling code, we make each chunk of code less dependent on others, and this way, when we make changes, they have less impact on the overall code base. Okay, so from my experience on mobile applications at scale, there are always three main responsibilities in an app. First of all, interacting directly with an API. And I mean a REST API or a device API. We're gonna call that the data layer. Then transforming or manipulating the data that the API provides. And we're gonna call that the domain layer. At last, we have presenting that data or triggering events that involve a data request. We're gonna call that the presentation layer. Okay, depending on the architecture you choose, these components can have different names. Or maybe there are two components to handle specific aspects of one of the responsibilities. But those are what we call implementation details. The essence will remain independent of the architecture. Okay, the main purpose of this talk is to mention the common architectural choices you have to do when you organize your projects. I'm gonna mention what you should and you shouldn't do to structure your app the best way possible so you can have the foundation to build a scalable and maintainable application. A small disclaimer, these are subjective choices, so bear with me on that. First of all, as I said before, you can create different layers to handle three main responsibilities in your app. Defining layers is a critical step as you may want to keep them as simple as possible without compromising maintainability. What has worked for us at BGV is an architecture that has 4 layers. The data layer is the one in charge of interacting with the APIs. It's the first layer we use. And it's also the infrastructure that supports our application. Then we have the domain layer. That's the one in charge of transforming the data that comes from the data layer. And finally, we want to manage the state of that data and present that on our user interface. That's why we split the presentation layer in two. A business logic layer that manages the state and a design layer that renders UI components based on that state. And we call that presentation as it is. That's the only layer that we leave in the actual lib folder and not on a separate package. That's why we call that the application layer. Both our business logic layer and domain layer manipulate data, but the main difference is that the domain layer interacts with the APIs and adapts that data so the business layer can define use cases or specific features. Also, the business layer captures the inputs coming from the UI to further tell the repository to change something about that data contained in its state. Okay, depending on the implementation of the API, we can manipulate data without creating an actual API package. But we will talk more about APIs and packages in the next aspect of the talk. Okay, avoiding mixed responsibilities. This is the most common cause of chaos in projects. Not having a proper separation of concerns provokes errors that are difficult to track. For example, some functionality that would ideally be on a data layer component is located on a presentation layer component, causing an issue that at first sight seems like a presentation issue, but it's actually a data issue. So, small TLDR on this is don't leave data or domain interactions to widgets. They shouldn't have any responsibility on this. Okay, so being consistent. You define patterns and layers for your projects, right? So follow the patterns you define for the project. Don't take shortcuts within the layers. They should have a chain of relation that prevents interaction between layers that are not directly related. For example, for the presentation layer, uh, it shouldn't call or interact in any way directly with the APIs on the data layer. If we establish that our data layer will be a dependency of our domain layer or a dependency of our repository, in other words, we must respect that in all the features we develop. Things like naming are key in this aspect because they make easier to know where things are in a project. Remember, naming is just a convention. In the end, some developers call the data layer infrastructure, and it's okay. It's just a name. But try to keep that naming consistent for your architecture. If we're not consistent, the code base gets messy, more difficult to navigate through, and our teammates will straight up hate us for not following the rules. Okay, so building with reusability in mind. This advice is for the data layer specifically because it is the most recycled layer for projects, as it is a raw implementation that can be used in many domains for different purposes. That's why we isolate our data and domain layers on packages, so we can import them in other apps. Sometimes we build these layers tied to a specific use case, adding local storage solution, for example, and we can create a generic API to store encoded JSON strings instead of expecting a specific model. So we can reuse that API as a local storage API in other domains. Keep it generic, in other words. Okay, so using the right amount of abstraction. When we develop a new feature that uses an external package as API for the data layer, we have two choices. First of all, create a repository that has that API as a direct dependency, and then create an API wrapper for the package. In this example, I suggest you go for the first approach if the package or plugin you're using as a dependency has a clean and simple API. It doesn't need too many dependencies to test it, or it doesn't need any configuration for the classes it uses for the functionality you have. Also, if it solves a specific use case and you're willing to have it as the unique implementation of your API. Those are the only scenarios where you can go for a package as a direct dependency for your repository. In this case, the in-app review package is a super clean API that can fit a repository that needs it to work. Otherwise, for this example, it's better to create an API with a class that wraps that dependency or many other ones and leaves all the noise there to avoid having all of those implementation details in the repository. In this case, Clock API, Platform API, Local Time Zone API, and the Flutter Local Notification plugin. So these are 4 APIs, a lot for a repository, and if we can wrap all those APIs in a package, in an API package, that's perfect for our data layer. Okay, so don't over-engineer. This is tricky. This is related to the previous choice because we don't want to abstract less than we should, but over abstracting, or what we call over engineering, can be time consuming and not worth it. An example of this can be models. We usually create JSON serialization and deserialization functionality for them, but we know we can change to an API with a different format, say YAML, for example. To be honest, how often we're using anything different than JSON to parse data? Rarely, right? So abstracting the base properties of the model so we can later add the JSON implementation to it sounds overkill and a waste of time if we never change the current format. So just know when you're over engineering. This is an example. Here we have the serialization and deserialization methods, and basically that's everything we need for this tag model. So keep it simple. Okay, so to use or to not use packages. Okay, I have to say this because not all projects are the same. Speaking of over engineering, if you consider your project is small, maintaining it with packages can be a bit overkill. But I personally always use packages because I'm obsessed with component isolation, and things like migration are really easy if you keep this kind of structure for like a mono repo or something like that. And this is a good example. You can have, let's say, John from accounting migrating the accounting repository to Very Good Analysis 2.4.0, and I guess Stuart from retail migrating the retail API to DO4 at the same time. So you can tackle fixing lints and null safety refactors one package at a time without stepping on each other's toes. Anyway, it ends up being your call, so choose wisely. Okay, choosing the right tools. Let's be honest, we can do it all by ourselves. It's important to have strict criteria to decide on which package or tool you are going to use to solve a problem in your app. And I suggest taking into consideration things like activity on the GitHub repository of the package, pub.dev metrics, test coverage. It's a really important aspect. And also who's maintaining it. There are many more, but those are what I come up with. Okay, so see what the experts are doing. I might be a bit biased on this one, but when I wasn't a unicorn yet, one thing that helped me get my projects to the next level was to check out repositories of remarkable developers from the community, like Remy Rousselet or my now teammate Felix Angela. And most of the Flutter community members have a lot of public repositories on GitHub that you can study and criticize to learn from and also improve. I can tell we at VGV have some interesting ones that expose our best practices and also how we build stuff. And we're open to answering your questions about those. Okay, so refactor, because we're humans, we make mistakes. And recognizing and learning from those mistakes is as important as layering your code. Your first approach might not be the best one you come through, and you need to criticize every idea or practice you're following to see if it's necessary or if it actually makes sense. But after all, remember you don't need to be perfect to be consistent and make your project successful. I strongly believe we should do our best when building apps, but there's always a level of good that will be enough to help you succeed. So don't be so hard on yourself on this. And this is an important one too. Share what you learn. I'm sure we have a lot of ideas, uh, new ideas from this talk, and you will have even more if you keep investigating. I'm excited to see what new pattern or practice you discover. So make sure you do some type of tutorial about it so the community can learn too. Or just tag me in a Twitter thread explaining it. That works too. So it's fine for me. And a quick recap of our talk. Basically, define your architecture with clear layers. Um, then follow your rules, the rules you establish for your project, and not your gut. Stay firm to your actual patterns and the rules you establish for your projects. Also, reusability may seem overkill until another project demands it. Probably if it's the first project you're building with a layered architecture, probably the product the productivity or the, I don't know, maybe the advantages of reusability by encapsulating on packages or something like that may not seem like it's working, but you'll see, you'll have another project that if you keep it generic and keep it reusable, it's gonna be really handy when you need it. So yeah, uh, keep that in mind. Also, try to find the sweet spot between under and over abstracting. Uh, and then choose based on pros and cons. That means be objective. Have like a chart with all the things you're looking for in a tool, so you can have the right tool for the job, and give them, I don't know, maybe points to see which has the most points, and value many things that you actually need on your project. That's gonna be like really productive. And at last, don't go hard on yourself. Leave room for improvement, because we're not perfect. Uh, we're always looking for ways to make things better. So yeah, keep that in mind. Okay, so here you can find examples that are using layered architectures. They are different from one another because they have different architectural choices based on the requirements that each one had. But I hope you learn a lot from them and the different, I don't know, maybe challenges each one had and how they solved it. And also, if you have any questions or want to keep in touch with me, you can reach me out on Twitter, and also follow me on GitHub for more code samples, or yeah, basically that. Yeah, it was really great being part of the Flutter Festival London. Thanks so much for inviting me, and keep enjoying the other great talks. See you.
Oops, there I am. Thank you very much, Marcos. So we've got a few minutes to the next one, so I'm going to put up the card, and Yogita is going to be joining us in about 6 minutes for the next video, and we'll see you then. Let's welcome Yogita to the stage.
Hello everyone. First thing, thank you GDG London for giving me this big opportunity. I'm Yogita Kumar and I have more than 8 years of experience in software industry with the expertise in web and mobile applications. I started Flutter nearly about 4 years ago and I found it really interesting and evolving. Today we are going to see responsive designs in Flutter. Let me share my screen. Responsive designs in Flutter. Why we care about the application responsiveness? As the data of the worldwide screen resolution stats, we can see in the market there are number of devices available with different platform capability, with lots of screen sizes. And as a developer, when we develop application and this application get installed through App Store and Play Store on the user devices, user expect that this application adapt and responds to their device. And what if it is not happen? User will be disappointed. And that is really a big nightmare for us as a developer, isn't it? 80% of customers won't prefer poorly designed application for their business. Now, as all of us know, Flutter is scalable from mobile application to tablets to web application, desktop application. After all, while developing the application, we have to take care of these things, of the different sizes and the different platform capabilities of the devices. While developing the application, we have to consider the screen size of the device. Little bit we have to tweak about the navigation strategies. The application navigate in mobile in different way, in desktop application little bit in different way. We have to consider the orientation of device so that according to we can display the layout. But first thing, we have to keep in mind what is the difference between the adaptive application and responsive application. Adaptive application based on the platform capabilities, responsive application based on UI representation. Adaptive application changes their functionality according to the device platform on which it gets installed. Suppose your application gets installed on the smartphone, then only change the capability and give you functionality for GPS tracking, QR code reading, biometric ID, and etc. Responsive application considers your device size. It looks different in the mobile application, different in the desktop application. Totally depends on the screen size. Our application can be adaptive or can be responsive. Otherwise, both together, adaptive as well as responsive. Otherwise, none of this. So let's see how we can design responsive Flutter application. Once I got a client and he said he wanted to display one image and some text on the application. I said, okay. Then his second requirement is that this application should be accessed through the user mobile, the tablets, and the big screen kiosk. I said, okay, this is only screen matters, screen size matter. So I just go with the media query. In media query, I can get the screen size and I can accordingly design my application. By the screen size and width, I can decide whether should I display the vertical layout or horizontal layout. Here in the example, you can see I create one class responsive demo which extends a stateless widget. And in the screen size variable, with the help of media query, I'm going to save the width of the size of the device. In the scaffold body, I just check with the simple condition If the screen size is greater than 600, then display the horizontal layout. If not, then display the vertical layout. From where I get this 600? This 600, as per Microsoft document, these are the breakpoints for our screens so that we can decide the small, medium and large screen and we can design our application. Let's see what I did in the horizontal layout and vertical layout. In horizontal layout, I consider landscape mode, so I put one row, and in that row, I put two widgets, image view and text view. So I can get the layout in the landscape mode. In vertical layout, I put a column with the same children, image view and text view, so that I can get a view in the portrait mode. Image view, nothing but the network image that I randomly picked from the net. Text view is the column wrapped with a single child scroll view and which contains text and some more text. Let's see how it works. Looks good in the portrait mode. Rotate a device, and in landscape we are getting some error. We have to solve this, and for that I just wrap the image view and text view with the expanded widget in both row and column. Now this expanded widget is specially used with the row and column. It expands the child of the row, column or flex them to occupy the available space. Let's see how it works. Good in the portrait mode. In landscape mode, we have to rotate the device and the error gone, it works. The second approach is layout builder. Now media query gives me size of the screen. But many times while designing the application, we have to consider the size of the parent widget. And accordingly that we can design the child widget inside that. To get the size of the parent widget, I use the layout builder. And as you can see, the same class I'm having, responsive demo. And instead of media query, I'm using the layout builder. The builder function takes two parameters, context and the constraints. And with this constraint parameter is the more important for me right now. With this constraint parameter, I can get the max width, mean width, max height, mean height. And by checking with the simple condition, I can display the horizontal layout, landscape mode, or vertical layout, portrait mode. Now, with this, I can able to show the output, the UI components in portrait mode and landscape mode successfully. But what if the mobile screen is too narrow? How I'm going to do that? So it's the simple one. Just add one more condition with the if-else statement. Here I'm going to check whether the max width is greater than 300 but less than 600. I'm going to display narrow layout so that it can display over one column only. Now that client come against to me and he said he want to display some videos, but that video should be played only in a landscape orientation. Is the user requirement, we have to do that. Now in this case we have to consider the orientation of the device. So I used the orientation builder. Orientation builder, the builder function get context and the orientation object. with the help of orientation, I can get the device orientation. And I will check with the orientation values, the portrait or landscape. And accordingly that I can display the layout. If it is portrait, then displaying the vertical layout. If it is landscape, then horizontal layout. The orientation I'm getting in through orientation builder is totally different from the orientation that I get from the media query. While designing the responsive application in Flutter, there are several different widgets that we can use. Some of them are fractionally sized box, aspect ratio, fitted box. Now, this is all about stateless widget. As you can see, we just take the image and the text, which is not preserving any state. Now client comes to me and he said he wants one form to get the user first name and the last name. So I design one form under the image view. Design one form with the form widget and which contains the column of the two text form fields. Okay, let's see how it works. Looks as expected. Put the first name, last name, and I just rotate the device. Where is the data go? I really don't know. I didn't do anything. I just rotate the device. Something is messy. We have to fix it. Here is the keys come in the picture. In Flutter, key uses to preserve the state of the stateful widget. And this is unique to all widgets. Key is specifically used when we are moving the widgets around the widget tree or replacing them. There are mainly two types of keys in the Flutter, local key and global key. Local key again divided into value key, object key, unique key, and page storage key, where value key takes the value as an integer or string. Object key holds the object data that is more complex than the primitive data types. Unique key, this is unique for the application, unique for the widget throughout the application. Page storage key. Page storage key contains the scrolling location of our widget. And global key creates the unique reference for the widget throughout the application. Let's see, and we attach this value key with the key parameter into this text form field. For the first text form field, I attach the value 1, and for the second one, I attach the value 2. Let's see how it works. Application is in portrait mode, and I just put the first name and then last name, and I rotate the device. Again, no data preserver. Why? Why this data is just disappear by rotating the device? Let's see. The main reason is widget tree. When widget tree in the landscape mode, it shows the row. And when we rotate the device and it comes into the portrait mode, this row widget turns into the column. And that's why it's not preserving the state of that stateful text form fields. So what is the solution for that? As you can see, all the widgets are similar, just this column and rows are different, they are changing. So we have to fix that. For that, I replace the row and the column with the flex widget. Flex widget, and for that, for row, I mention the axis as a horizontal, and for column, I mention the axis vertical. Let's see whether it is solve a problem or not. I put the first name and then the last name and just rotate the device. Oh yes, did it. We can manage to preserve the data for the stateful widgets. That's good. So in today's session, we see the difference between the adaptive and the responsive application. We see how to design responsive application in Flutter using the media query, layout builder, orientation builder, and also how to preserve the state for the stateful widget with the help of keys. I'm sure you will get more idea for designing the responsive Flutter application. But if you have any question, please drop me a message on the Twitter. And at last, I will say you, whenever design the Flutter application, don't consider about a specific device. Otherwise, you will be always get in trouble. Thank you. Bye.
Thank you, Gita. So we've actually we've ended that session a little bit earlier than I was expecting. So we've got about 45 minutes for lunch. So we'll be back at 1 p.m. and I guess we'll see you then. I wanted to mention, don't forget spatial chat. We're there, ready to chat. Hello, hello, welcome back. I hope you all had a lovely lunch. We're here to the next talk. Rutvik, I'm probably pronouncing his name terribly. I'm sorry, my friend. Rutvik's going to be talking about creating beautiful audio waveforms in Flutter. I'm quite excited to see this one. Let's see how that goes.
Hello everyone, myself Rutvik. Hope you guys are doing fine and enjoying the talks by the other speakers. So today we are going to talk about how to create beautiful audio waveforms in your Flutter apps, just like the one that you are seeing on the screen right now. So before we start, a little about me. Who am I? I'm from India and I've been working with Flutter since the start of 2020. That is almost when the Flutter version 1.17 came out. And since last 2 years, I've also been working as a Flutter freelance developer. Within this time, I got the opportunities to work with some really nice people and with some really awesome projects. I am also the author of the Flutter Audio Waveforms package, which is just about the topic that we are going to cover today. Whenever I get free time, I also write technical articles about building some nice UIs, animations in Flutter, and other interesting stuff. And last, I also like to listen to music a lot, and that's like one of the reasons why today's talk is happening. So now let's start with the talk. First of all, where these audio waveforms are used that we are going to talk about today. In the music apps like SoundCloud and Audio Rack, you can see such kind of visualizations being used. Now, for the people that like to skip through the audio, these visualizations are really helpful. And also in the audio and video editing applications like the Descript and Audacity, these visualizations are an easy way for the creators to really go back and forth and edit the audio, as they can see the highs and lows of the audio very easily with these visualizations. So a little bit of overview of the talk. First of all, we are going to understand how the audio is understood by the computers. Secondly, we are going to talk about how to get the waveform data that will be necessary for us to visualize the waveform. We will use some open source program to do this that we'll talk later about in the talk. Third, we are going to process this data to make it easier for us to use. And last, we are going to visualize it. That's like the most interesting part, right? So, understanding audio. We as human beings perceive audio as a sound wave that is curved. But when it comes to computer, they understand it differently. For them, it's just another data point. When we are recording an audio, we do a process called sampling. Now, what is sampling? Sampling is the process of capturing the amplitudes of a sound wave at a given point in time. And the number of samples that we calculate every second is known as the sampling rate. Usually the sampling rate is around 44.1 thousand hertz or the 48,000 hertz. And another important thing here is that these samples are captured at equal intervals in time. So let's say if we are capturing, if our sampling rate is like 48,000 hertz, then for every 1 by 48,000 part of a second, we would be capturing a sample point. Once these points are captured, then these are stored or transmitted for further use. Now let's talk about how we are going to extract the waveform data from an audio file. To do this, we are going to use an open source program called Audio Waveform from BBC. Let's see that now. So this is the program that we are talking about. It's a C++ program that you can use to generate this waveform data, and also you can render the waveform images from an audio file if you want that. For our case, we will be generating the waveform data. About the installation of the program, it's really simple. It's available for multiple operating systems like Ubuntu, CentOS, Mac, Windows as well. About the usage of it, it's really simple. Once you install the program, You just need to provide it an input file. That would be our audio file that we want to get the waveform data from, and the other would be the output path for our waveform data file. The waveform data can be captured in different formats. Here we are going to get the JSON format of it. So now let's take a look at how the JSON format of this waveform data looks like. So here on the right hand side, I got one waveform data extracted from an audio file of a duration of 30 to 31 seconds. Let's go over some of the important things that we have got here. First of all is the channels. This represents the total number of waveform channels that are present. Now, what is a channel here? So you can consider the channel is an audio source that is capturing the samples. And waveform data can have multiple channels within it depending on how we record the audio. Second, what is a length? Now, length is the waveform data, that is the number of minimum or maximum value pairs that are captured per channel. Next is the sample rate. As we talk about, the sample rate is the number of samples that we record every second. Bits. The bits represents the largest value of the amplitude that you can capture, right? If we are using 16 bit, then the largest value of the amplitude that we would be able to capture would be equal to 65,536. If we increase the bits, let's say to 24 or 32 bit, then that also means that we will be able to capture the sample points with a larger amplitude value. Thus, that would preserve the original sound quality as well. Last is the data which we will be making use of to visualize the waveform. These are the sample data points collected from the channels that are present. Now let's talk about how we are going to process these samples. First of all, why do we need to process these samples? As you can see in the previous example that I showed you, the sample points that we got were in the number of thousands, like almost around 70,000 sample points were in that data list. First of all, but if we talk about the audio file that has a duration of 2 to 3 minutes, then those sample points would be much higher. So what we would do is we are going to average down to the list to the number of total samples that we want in our final sample list after processing. So to do that, we are going to divide the original sample list into blocks of certain size, and then average those blocks, average the sample points within those blocks, and add them into our final list. On the right hand side, you can see I got one simple function here called process samples that is just doing the same. We are declaring some things here. First of all is the filtered data, that is the final list where we are going to store the average points. Next is the total samples. How many samples do we want? Based on the total samples, we are going to calculate the block size, and once we got that, we are going to iterate over the original raw samples and get the average size for each of these blocks and put that back in the filtered data. So the next step is to normalize the data. First of all, if we have a lot of silence in our audio files, then what's gonna happen is the resulting averages of the data point that we calculated in the previous step are gonna be very small. To get around this, what we are going to do is scale our filtered data sample points within a value from -1 to 1. How are we going to do this? Let's take a look at that. On the right hand side, just after we get the filtered data, we are going to find the maximum amplitude within that filtered data and take the inverse of it, and then multiply every sample point within the filter data with that multiplier. That would give us the sample points list that would have the values from the range of -1 to 1. Also, this would make it easier for us to handle the sample points when we are going to visualize it. Now on to the last part, that is visualizing the data. And this is the most interesting part that you guys have been waiting for. So now let's start with it. So I've got a sample application running here that is visualizing the sampling point for the different music files that I'm passing to it. As you can see, as I'm changing the sampling points depending on the music, the waveform also changes. Now this type of visualization is called the it's polygon waveform visualization. What we are doing here is we got our sampling points which will represent the coordinates along the y-axis, and we are plotting them in an xy coordinate system and using a line to connect these points, and that gives us this kind of visualization. I've also got another visualization done here that is called the rectangle waveforms. Instead of drawing a single point and connecting those, what I'm doing here is drawing a rectangle at those places. This also updates as I change the sample point that I'm passing to it. Now let's head over to the code and see how we are implementing this. As you can see, I've got this waveform data captured for these three different music files that I had. In our main code, we have this parse data function. What it is doing, it is loading that waveform data JSON file depending on the music I pick, parse decoding it with the JSON decoder, and taking in the sample list, the original one, and passing it to our process samples function. Now what does this process sample function is doing? It just doing the same thing that we talked in our previous slides. That is, first of all, it is averaging down the original samples based on our total samples and the block size that we calculate on, and later it is normalizing this list, the filter data list that we get after averaging, within a value from -1 to 1, and that gives us the final samples list that we are going to work with when visualizing it. So now let's head over to this specific waveforms and see how they are visualizing this sample list. If we check the first waveform, that is the polygon waveform, then we can see that we are using something called custom paint. Now for those of you who might not know it yet, now what custom paint is, it is a widget that provides you with a canvas and takes in an additional painter argument that describes the drawing operations of how we want to draw this visualization. Also, I'm setting a size for our waveform, that is the maximum size that we can get, that is of the screen, and the second is the height for it, that is 300. So let's take a look at what polygon waveform painter is doing. It is an instance of custom painter. We need to override two methods here. First is the paint and other is the should repaint. If we take a look at the paint method, then it has all the drawing operations that we are doing to visualize this waveform. And secondly, the should repaint method decides whether if you want to repaint our drawings or not. That is depending on if there is any mutable data that is changing. In our case, we are just returning true here. So let's dig a little deeper into the paint method. What we are doing here, we are first declaring a painter, that is you can consider it as a brush, setting the style of it to a stroke, giving it some stroke width, and setting it color to colors.blue. Now this next implementation would differ based on the type of waveform that you are trying to visualize. I mean the visualization that you are trying to achieve for the waveform, right? In our case, for the polygon waveform, we want it to be a line that is connecting these sampling points in an xy coordinate system, right? So to do that, we got here something called path, which we are going to draw these lines, and we are calculating something called sample width. Now what is the sample width here? Now as you may have remember that in the process sampling, we are capturing the samples at equal intervals in time. So that means when we are plotting these points on an x-axis, that represents the time. The sampling points, the consecutive sampling points would be placed at equidistance from each other, right? So to get that distance, what I'm doing is getting the width of our canvas and dividing it by the number of samples that we have. So that gives us the sample width. Next up, we are iterating over this sample list to draw those lines. We are doing two things here. First of all, getting the x y coordinates here. For the x, what we are doing is taking the sample width and multiplying it by the index of that sample point. So that would give us the distance of that sample point from the origin. And second is the y coordinate. To calculate the y coordinate, we know that our sample points are now within a range from -1 to 1, and we are multiplying that by the half of the height of our canvas. And then once we get this x and y coordinates, we are passing them to this function called .line2. Now what this function is doing is drawing a line segment from the current point to this given point, that is the xy coordinates that we are passing it. Once that is done, we are doing something called shifting in here, as you can see. Now why do we need to do the shifting here? As you may remember that the origin of our canvas is in the top left corner. So when we are drawing these lines, then those will be drawn according to that. But we want our waveform to be aligned within the center of the canvas. To do that, what we are going to do is shift the path along the y-axis by half of the width of the canvas size. We are doing it with the help of this shift method here that takes in the offset as an argument, where we are providing the x offset to 0 and the y offset as the half of the height that we have. And finally, we are passing this shifted path to the canvas.drawPath function or the method. This takes in the path that we want to draw and the painter object, which decides how the path is going to look like, the stroke and the color of it. And that gives us the kind of visualizations that we have right here. So that was about the visualization of the polygon waveform. If we take a look at how the rectangle waveform is working, it's the same. We are making use of the custom paint along with the custom painter. The paint operations are it for a different, as I said, that they might change depending on the type of visualization that you are trying to achieve. We got our painter here, the sample width calculated, and then we are iterating over the samples and drawing a rectangle instead of those points. To draw a rectangle, what I'm doing is we have this from left top. We have this method here that draws a rectangle based on the left and top distance and the width and height of that rectangle. Now for the left, we are going to pass it the x coordinate that we calculated here, and from the top would mean where we want to draw this rectangle from in the canvas. A value of size dot height by 2 would mean that the top would be at the center of our canvas, and the width of it would be the sample width, and the height would be the y coordinate that we calculated up here. And secondly, with that we are also passing in the painter as well here, and once we get that, we get the visualization of this rectangle waveform that you can see right here. Now that was about just the two waveforms that we visualized, that is the polygon waveform and the rectangle. And if you want to do other visualizations, then the Drawing instructions would change, but the basic process of that would remain the same. First of all, you get the waveform data, process it, and implement your custom painter that is going to visualize that data depending on your requirements, right? Now, this was a really simple example that I showed you. Now, I would like to show you the package that I've been working on since last few months that really takes this visualization to the next level. A little bit about Flutter audio waveforms. What is it? It is an UI library for easily adding audio waveforms to your apps with several customization options. It supports all the platforms that Flutter supports, so that is really great. I'll walk you through a demo that demonstrates the capabilities of the package and the customization options that it offers. As of this moment, the package supports 4 different types of waveform visualizations. That is the polygon and rectangle, the basic two ones that we saw in the earlier example. And the others are the squiggly waveform, or that's what I like to call it, and a curved polygon, which is basically like a polygon, but with instead of having a sharp edges, we have some really nice curved edges around the sampling points. Now let's talk about the customization options available for these waveforms. You can change the height for it, I mean that's the basic thing. Change the color for it, and also add some nice little gradient to your waveforms. Let me just increase the width to max, and yeah, that's better. You can also make your waveform absolute or invert. Now what does absolute does? It draws your waveform in one absolute direction, and toggling the invert, it just flips your waveform upside down, right? Now there are some specific customization options that are available to each waveform. For the polygon, we have the ability to change the style for our paintbrush. Now instead of stroke, I could change it to fill, and that gives us a really nice effect to our waveform. As you can see, with some gradients, this effect really looks awesome, I mean, yeah. For the rectangle, just the regular ones from the polygon, you can change the colors, add gradients, absolute, invert, and there's this option to change the border width for the rectangle waveform. As you can see, there's a little border around the rectangles. Just let me change the gradient to something more. Yeah, that's better. So as you can see, there is a little border around our rectangles whose width you can control, and also change the border color as well. Talking about the squiggly waveforms, for this specific waveform, you can change the colors for it, absolute, invert options as usual, and change the stroke width for it, which adds a really nice touch to it. And last is the curved polygon. You can change the colors, absolute, invert, and change the style for it as well. Now beside this customization option, there's also another interesting feature that the package supports, is showing an active waveform for a playing audio. Now instead of just talking about, let me just demonstrate that to you. So let me just set up some things, change the gradient a little bit, and yeah, as you can see, the active waveform is drawn as the audio is playing. And this is a really interesting feature that I really enjoyed working upon. I'm just gonna let this song end. I mean, it's one of my favorite musics. So that is it. Now let's take a look into how these things are implemented in the package. We'll just go over some of the little things. Won't be looking into other implementations, as that would take a lot more time. So let's take a look at how the polygon waveform is implemented in the package. Most of the things are the same. As you can see, the samples we are taking in, but now there are some additional arguments that we have, which for to support the different customization options that we have. Within the paint method, the instructions are pretty similar to what we did earlier, but at this time we also have a gradient. So we are adding a shader to our paintbrush, and within the for loop we are handling some edge cases that I came across when adding some of the customizations, but the rest of the implementation is just the same. Same goes for the rectangle waveform as well. The painting instructions for drawing a rectangle waveform without any customizations is just the same. We got our paintbrush defined, we are iterating our samples and drawing the rectangles at those points, right? But as we now have a support for border around our rectangles, to achieve that, what we are doing here is defining another paintbrush with a painting style to stroke, and then while we are drawing our rectangle, we are also drawing another rectangle, but the paintbrush that we supply here is the one that we created for the border, so that would give us that nice little border effect around our rectangle, right? So as you can see, when you are trying to create different waveform visualization, the process till the last point is fairly the same. uh, the instructions, painting instructions might change depending on the waveform that you are trying to visualize. You would have to figure out some things, handle some edge cases, do a little bit of math. For a fact, when I was implementing the squiggly waveform that I showed you earlier, it was the most trickiest one to implement. I had to figure out a lot of math for it, but that was the most fun part of it, right? With that, if you are curious about some of the implementations in the package, you can always check it out. Some of the things I'm still working on, but I'm happy to receive any feedbacks or any suggestions or improvements that you may want to see in the package. So, with that said, I would like to conclude today's talk about creating beautiful audio waveforms in your Flutter apps. I hope you guys enjoyed the talk and learn a thing or two from it. If you have any other questions, I'm always active on Twitter. You can just ping me there. I will also be sharing the slide deck on the Twitter as well. So, yeah, have a great day, guys. Thanks for attending the talk once again, and see you next time.
Thanks very much, Vic. He's actually over in the spatial chat right now, so if you want to have your questions answered right now, jump on there. Otherwise, follow him on his social media. So we've got a couple of minutes to the next one, so I'm going to put a title card up, and we'll get on to the next one, which is this one. So we'll see you back here in a few minutes. welcome back. So this time round, our next speaker is Laurent. If I'm pronouncing that right, I hope that's right. And let's get that going.
Hello everyone, my name is Levent. I am from Turkey and I am very glad to attend this festival. Thanks GDG London. I hope all you well. Today I am here to speak an amazing topic, package development with Flutter. If you're ready, let's take flight. If you are already a Flutter developer, I mean, if you are developing applications with Flutter, I think you are familiar to package usages, right? Let's look at the default Flutter application, the counter app. Like every Flutter application, that counter application has a pubspec YAML file. If you look at that YAML file, you can see two type of dependency section. One is dependencies, the other one dev dependencies. Okay, we already know this. Maybe you can think you are just using two packets for your project. One is Cupertino icons, the other one Flutter lints. But your project is carrying more than these two packets. What's going on? Let's dive into. If you type flutter space pub space deps command in your terminal in the project, you will have a very long list. Please look at the slide. Yes, there are many dependencies. But you didn't type that on the pubspec YAML file. What is the source of this? What is the reason of these dependencies? Yes, we are coming to good section. It's related to own packages. What I mean, please look at the Flutter lints package. I want to give an example on that package. We just typed Flutter lints package. Actually, it's coming default, but before I think before a year we were manually adding this linter package. Currently, it's coming by default Flutter application. Yes, we are using Flutter lints. We love lints. It's very important for clean coding. I suggest you. But when we look at the long list, we see lints package. It's different from Flutter lints package. But we didn't add that package or pubspec YAML. Yes, we are coming to the point. Like applications, also packages can use the other packets as dependency. So, lints package is a package for Dart projects. It brings some lint rules for Dart applications. But Flutter lints roadmap is that yes, I am using all Dart rules with lints package, and I am adding some other rules for Flutter applications. Actually, we can define the Flutter lints package contain lints package. Actually, it's not so correct. Flutter lints package depends on lints package. I think it's more correct. Yes, for this situation, you can use lints package, not Flutter lints. You can also use lints package in your project directly, because as I mentioned before, your project is carrying all these packages. Okay, let's continue. Yes, there we are speaking all dependencies. If you want to group these dependency, we can separate them to two sides. If we use a package directly, we can call that package embedded package. On the other hand, if we don't use a package directly, if it's dependency of another dependency, so we call them transitive dependencies. Okay. Carrying too many packages is not a good thing. It can increase the size of the package, the application. Also, sometimes we can have some conflicts for dependency versions. So you should manually and periodically check your dependency. Maybe you could have removed a feature which is dependent on a package. So I want to suggest you a package dependency validator for if you run this package by adding dev dependencies, you can detect your unused packages, and you can remove that package without looking without diving to your application. This package will give you an idea about that. Okay, I said dev dependencies. So if you don't know what is difference between dev, I want to try to explain the difference between them. I want to use as short definitions for these. If you need a package and you want to use that package in your production, I mean your application, your product for your stores, so you should add that package in dependency section. But if you need a package for your development process, you should add that package to dev dependencies, because there is no relation for production. For example, I want to give an example for this. A linter is a good example for this, but also we can use Flutter icons to create, not use, to create icons. Also, build runner, if we need generate some files, G files, we can get any assistance from this kind of packets. Okay. If you are ready, we can start to create our own package. It's easy as creating an application. Normally, we are typing Flutter space create space my app, the project name. It's necessary to create an application, or you can also use Android Studio or Visual Studio Code interface, no matter. Creating a package is very similar to that. Just write same command, and you should add dash template equal package name. This is enough for creating a package. But also I'm using Visual Studio Code, so I want to give example. I want to show a screenshot from that. When you select create new Flutter project or create new Dart project, you will see these options, and if you select third option, the Visual Studio Code will create a package for you, or you can create that file and folders manually, no matter, but it will save your time. after creating a package, you will see these file and folders, this file folder structure. I think it's very similar to applications, because it's also a Flutter project, an application and a package. These both of them are a package, a Flutter projects, right? Okay. I want to mention that if you develop a package which contains native bridges, what I mean, if you want to create an image picker or something with requires an communication to native site, the platform site, we call that kind of package plugin packages. But today we are talking about pure Dart and Flutter packages. If you create plugin packets, you can see Android, Windows, the platform folders here. I want to remind that, but I say again, we are today we are talking about just Dart and Flutter packets. Okay. Like application development, we will spend most of our time in library folder, but I want to suggest you something. Please create a Dart file which named same as your package name. For example, if I create a package which named my package, I should add a file into my library folder, my package. Okay. Also, I want you to add a source folder, the abbreviation of source folder in that library folder. Why we are using this? Why I suggest this? I will explain. Let's see the skin as a developer, as a package user. There are some features in your application, in your package, and developer want to use that, but developer doesn't know where is the related features are located. So we are giving just a point to access all these features in the package. So developer should just call import package my package / my package .dart. Just this definition enough to reach all features of that package. But we should add another lines for these my package Dart files. Export lines. These are very useful imports, export. These exports are very useful for also for applications. I use them frequently. Yes, I know it can take your time, but I want to suggest a plugin, not for Flutter. This plugin is for Visual Studio Code. If you use Dart Barrel file generator, it will create you the export files. It can save your time. I am very glad to use that plugin. Yes. After creating the package, adding features, you should give a version number to that package. You can start at 0.0.1. Yes. If your package is ready, you should update your package with the version number 1.0.0. It will show the other developers, yes, my package is stable anymore. You can use it. We think that there is no bug for this. Don't fear. Okay. It's important to understand the semantic version. I suggest you to investigate these structures. Yes, actually we are talking about the life cycle of package development. Yes, we created our package, we developed it, and we should prepare this for distribution. So we should create or fill the changelog file. Also, we should create or fill the readme file. If all the content and showcase are ready, it is time to distribute that. After distribution or publishing, we can detect or we can learn from other developers. We can have some bugs or another things to be upgraded or developed. We can update our package whenever we want. Thanks Google, PubDev is a very good place to get and share packages. But it is not the only option for distributing your package. You can also use a package from a GitHub repository or path, or using path. I mean a place in your computer. Some companies are using GitHub repositories to use their own packages, and they can keep that repository as private. I suggest this if your company or your organization maybe can have some private content. You don't have to share that package to everyone. But I suggest to share your package with the community. I think if you want to see Flutter alive, so we should support that by developing applications and sharing that packets on PubDev. It's very important, especially if this Flutter project is open source project. So we should support that project by creating or contributing packets. It's very important. If you want to publish your package on the PubDev website, there is a command for this, dart space pub space publish. But do not type and run this command directly. We should suggest to add a dry run option for this command. It will validate your package and it will warn you for potential errors. For example, maybe you can forget the license file, or maybe you can forget some configuration in your pubspec YAML. For example, maybe you can add something to add on a deprecated field. So first you should run dart publish publish command with dry run. If it's okay, you can run dart publish command and it will send your package to PubDev. After minutes it will be approved and you can share package with the community. Congratulations. Yes, you can share your package just having a Gmail account. But we suggest to get a domain to be a verified publisher. It's important because I will give you an example. Sometimes you can see some packets, yes, when we list them, we are looking the some important points when searching. One of them is, yes, can I rely on that package? For example, if it's verified, I can feel more relaxed. Yes, there is a domain, and they are, it seems they are reliable developers, contributors, so I can use that package. Also, if you are a verified developer, you will get a badge, and it will be listed on search page and package detail page. But as I mentioned before, you can publish and share your package without being a published verified publisher, no matter. Also, we suggest you to keep your package updated. When we need a package, we see the publish date. It's very important. If there is a period, if the package updated 2 years ago, we can't rely on that package. If 2 years ago, I think it doesn't contain null safety. So we suggest to be a verified publisher, and please keep your README and changelog file clearly and understandable. Also, you can add an example for that package. Also, the dry run can warn you for adding example for your package. Today I tried to talk about package development in Flutter. Firstly, we dived into the package usages. After that, we tried to develop our own application, and we learned that how can we publish our package to pubdev. I hope you enjoyed. You can always contact with me on my social media accounts. Thanks for listening. Thanks for supporting open source projects. See you.
Sorry, chaps. I don't know what's happened there. Oh, there we go. Let's. I think I was that ended a little bit sooner than I thought it would. So let's spin up the next video and get that queued up, and we'll see you back in 5 minutes. I hope everyone's having a lovely day. Let's get started with our next speaker, Mehmet, who's, I think, from Turkey. Let's see.
Hello, friends. My name is Mehmet Ali Bayram, and I am PhD student at Computer Engineering Department at Yıldız Technical University, one of the best universities in Turkey. And today I want to talk about Flutter CI/CD pipeline using Fastlane and GitHub Actions and make our development life easier and funnier. As a bunch of speakers also will talk about CI/CD pipeline. I won't talk about more detail. I will just a bit talking about what's the CI/CD pipeline, but I'm not going to deep dive into it because, as I said, there will be some other speakers will talk about and actually they talked and will talk about CI/CD. So here is a small image and figure that show you how it's going to work. Continuous integration and continuous delivery, actually. Deployment, sorry, complete continuous deployment, our today's topic. And my content will be talking about actually what's CI/CD pipeline. I'm not going to deep dive into it. Using GitHub Actions to set a workflow, I will show this one more detailed. Installing Fastlane and organize related folders to send our metadata to app stores. And most importantly, and probably will be most difficult part of your CI/CD pipeline, get case from Firebase, Google Play, and App Store, especially App Store. And using GitHub secrets to store our sensitive information to reach them when our CI/CD pipeline going to run. There is a small information. By the way, all images that I used in my presentation, you can reach them just clicking on the image. It will go to the image source, and I will put this presentation link to GitHub repo that I will show you and share with you publicly. Shortly, continuous integration is a validation of developer change by creating a special build process. This build process consists these steps. I'm not going to deep dive into each steps, but just fetching dependencies from repos, building your codes, running automated tests, especially unit testing, integration test, etc. on this build. Also, here is a really good topic that when you run your integration test, you can just take your screenshots and send them directly to app stores. Also, you are going to run your code analytics on GitHub Actions notification. After you will get an error or success. Continuous integration tool should send you an email or SMS for GitHub Actions. It will send you an email. And finally, packaging your build to next step is actually continuous deployment. Continuous deployment is a software release processes that uses automated testing to validate if changes to a code base are corrected and stable for immediate autonomous deployment to production environment. For this presentation, the production environment will be Firebase hosting, Google Play, and App Store. Here is a good GitHub Actions workflow. There will be events. I will show you how you are going to trigger it with pull request, schedule, or push, or issues. There are a bunch of way to trigger these events, and your workflow will begin to do its jobs step by step. And actually, Fastlane, I just want to talk about it a bit. Fastlane is an open source platform aimed to simplifying your Android and iOS deployment. It's completely free as it's open source. You are going to build it on your own machine and on GitHub Actions. Fastlane lets you automate every aspect of your development and release workflow. It has also its own tools to take your screenshots. And actually, this is the end of my presentation. It just was a small presentation that I talked before also. I'm just going to copy this link to put it. So let's get started to talk about the workflows. Here you need to firstly create a .github folder, and in the .github folder you need to create a workflows folder. Here it is. And in this presentation I will show you just 4 of all these workflows, how they are going to run and how they are going to trigger it. Fastlane folder, we are going to put our screenshots to send it to the app stores, and here is a metadata folder. Other one is a coverage batch. I will show you a small Dart file that I'm going to run it for every test running and update the coverage batch that will show you. Just give me a second. I want to show you coverage. This actually, it's, I don't know if it's real or no, but after you send it to the Google Play, it will just update this is with your actual code coverage percentage in your project. It will be real number. And after that, I want to show you how you are going to trigger your first of all, you need to trigger your tests. And for my case, there are a lot of trigger systems that you can do it. For me, I will show you that all other workflows going to trigger by end of the run tests. When if this run test completed successfully, the other workflows then trigger it and will work. I just put here another trigger system, and I strongly recommend you to go and check other trigger systems. On the top file of our workflow, this is our workflow names. Workflow name, it's run test, and it's going to trigger it on pull request of which branch I'm going to specify it to release branch. You can make it another branch, and type is closed. When closed this pull request, this will be triggered. That's mean it will just start to do its job. The first job is running tests, and actually the name of this job is also run test. It's not necessary. Some of these lines you don't need to use. If you want, you can just delete it. It's not so important for this case. And there is a conditional. I just want to show you that you can just trigger your run your jobs even with some small conditions. It will just look at the GitHub event that's going to be there. It will be pull request, and if it's merged, then it will run this job. Otherwise, this job can not going to work. So after that, you are going to specify which operating system you want to use on GitHub Actions. I just selected Ubuntu latest, and I will show you that also you can use macOS to build your iOS application to send to the App Store. Also, you can use Windows, but in this presentation I'm not going to show you Windows. I will just show you Linux and macOS. And for this job, actually run test job, there are several steps to do it. First of all, we need to create our checkout, git if the action is going to work or no. And later I'm going to install the Flutter. There is a good workflow. We can just access it. In this step, I just say, okay, I'm going to use this Flutter action and install my Flutter version. Its latest stable version 2.10.3, and the channel is stable, and I want to cache it to use for the next steps and for the next job. I will show you how we are going to read it from the cache again. And next step, I'm going to check my formatting. Just run the simple command line Flutter format, but also here is a bit tricky, because if you run the Flutter format, it will run normally and not change anything. But if there is some change, it also will go forward, not stop. But when you say okay, set X if changed in library and in test folder, actually it will format library and test folder. If there is any change, it will exit and your action will stop. And in the next step, it's going to analyze your codes for linters as its analyzes options here. If there is any rule that's broken, it will just also stop your action. It's not going to complete it. And after that, it will run tests and analyze the coverage. This is important. Just put it here, coverage, because when you write this, it will create a file that your test result will be inside it, and I will show you how you analyze it and put it the coverage batch. And in the next step, if I am going to commit and push the covariant pairs, if the coverage percentage changed, I will push it to my repo again. For this, I have written a small Dart file in put it inside analyze.dart inside env file folder, and after this file will change your coverage batch. You are going to run just git add and configure your git as a normally, and you will say just okay git push. And I'm going to show you this file, how it's going to work. Actually, it's just going to read the coverage folder. As you see, there is no coverage folder. After running this line, it will create a coverage folder, and there will be line coverage.info file, and you are going to analyze int and update your coverage batch. And after that, it will just going to and update this percentage. Actually, you can just check this file anytime you want, because I will also put it to the GitHub repo. And after completing this one, it's actually will go to throw another workflows. First of all, I want to show you deploy your application to work. Firebase hosting. Here is a trigger. It's workflow run. When the workflows, it's run test that I showed you. If it's completed, it will just run this workflow. I'm not going to show all steps again and again. I will just show you that you are going to run the full Flutter build web, and after create this one, you just need to use Firebase official action that's going to deploy your web folder to Firebase hosting. And here is important part that you need to use secrets, and I'm going to show you how you are going to use secrets. You need to use Firebase service account JSON file, and I just put here a link to get this, and just I will show you, but I'm not going to do more detail, because here is how you can get this file. I will just show you how you are going to put this inside your GitHub secrets, because when you come your GitHub repository, there are settings tab, and just go to the secrets and actions. As you see, for now there is no any secrets. I'm just going to make a secret here, Firebase service account. Here is important. When you follow these steps, you will get something like that, a JSON file. Just copy inside it and paste it here. You actually can convert your files and encrypt them, but for this situation it's not important. You can just by the way, this is just dummy file. It's not an actual file. I'm not going to reveal my information. It's so important. Just don't reveal any information inside here. Be careful and just put it in secret. And I'm just going to add it here. After that, we can use it directly from our workflows. As you see here, I'm just going to publish it to this Firebase project, and channel will be live. And after it is completed, I'm going to send my application also to the Google Play. I'm not going to talk about the before, just I want to show you that you need to install also the Java, and you will find here how you can install Java, and I'm just installed version 12. And there is another important part that you are going to put your case store file to the Git secrets, because as I said, you can just make it base 64 encryption, and again you can just convert it to the file k.gks, and after that you can just make a Android k.properties. This is important because you are not going to, when you run your application, I mean when you push it to the GitHub, you are not going to send these password files. It's important. As I said, this is just dummy information. They are not real, and never ever publish those information publicly. It's important, so because of that we are going to use Android, GitHub secrets. I'm not going to show you how put all of this, because I showed you all of them same. You will just create a new one and you are going to use it directly from here. And after that you are going to say just okay, Flutter build app bundle, as you did it normally in your local machine when you want to build your application to send to Google Play. But here is another third-party solution. We need to send our application to the Google Play. For this, I'm going to set up Ruby on my machine, in the server machine in GitHub Actions, and I'm going to okay, for this part I think we need to a gem file lock, and I just forgot to put it here. I will show you how you are going to create it and use it in here. Just those 2 lines is enough for this file, and it will just build your Fastlane in your machine, and you are just going to release your application sent to Google Play. For this also you need a Google Service Account key, and I just put here a link how you are going to get it, because it's need a bit long, but it's easy to get it. When you say bundle execution Fastlane supply, it will send your AAB file that when you run Flutter build app bundle, it will be here. It's important because when you written here a wrong path, it cannot be find your AAB file to send to Google Play, and you are just going to say my track its release, and it will send it direct to the release. You can make it for beta or also for alpha. It's completely okay. I just put it here because before it was alpha and I just make it alpha, but you can make it also for beta, alpha, or release version of your application. And those steps are for sending your application to Google Play. And the last workflow for sending our application to App Store, it's a bit complicated than the others, but it's also not a big deal. First difference is runs on macOS latest version. It's different from the other ones. Actually, you can normally use for all of them, you can use just run on macOS latest, but for macOS latest, I just realized that mostly it's stay in the queue a bit longer than Linux. I will show you that, but you can use it's completely normal. All of the other steps are same, but when you you will just say okay, just build my application and also it will install Fastlane in your machine, and you are just going to release your application to the App Store. You need to one important thing, Apple App Store Connect API key. It's like same, it's P8 file actually contain your case. You will just complete all of it, not just key. It's important, not don't copy just the case, complete whole key. I will also show you because it's important. You can make mistake. Just complete, make it completely copy. It's important, and just named it same and add secret. That's it. Another important part is the match file, because this match file need to be put on the GitHub, and it's also important make it private repo. It shouldn't be where it is. Here it is. Like create a Git repo. It's not important what name it is. It's completely okay. Just go. I put it here just how we are going to create your match file. You will just need to Fastlane match init. Before this, you need to install where it is. Install Fastlane your local machine, and after you install the Fastlane in your local machine, you will just go to the iOS folder and create the match files. I'm also going to show you how you are going to do it. Just go to the iOS folder and open it in Integral Terminal and put it here. When you click here, it will initialize your Fastlane match, and which one you want to use store your match file. I will just use Git in this scenario. You can also use Google Cloud or AWS. And here it is. It asks you about GitHub Git repo that you created to store your file. You are just going to you can also use HTTPS or SSH. It's same, it's not different. It depends on your how you are going to using the Git on your local machine. I'm just going to create it, and it's okay. Just your match file created. You can see in here a match file. That's it. And you will modify it as step by step. Here it will show you how you are going to do it step by step. And actually you will also need to put all of the Git URL secret to GitHub Action secrets here again. As you see, there are a lot of secrets that we are going to use because normally we are using all of them in our daily life to send our application to Google Play and App Stores. But for CI/CD pipeline, we will need them just one time, and we will put them in our secret, and we will use for every pushing our application codes to the GitHub. It will check and release directly to the App Store. We don't need to do anything else. And it's a bit important when you say that bundle execution Fastlane iOS release, it will send these environment parameters to where is the first line? Here's Fastlane. And here is in first file, when you say okay, environment mean is this environment, and it will got the, for example, match Git URL and use it. I think it's enough for my presentation. I wish this help you a lot in your daily usage of GitHub Actions and development life. and I'm just going to commit all of them and push them the first actual commit and send it to GitHub. Feel free to make any pull requests or create any issues on my machines. On my repo. I will try to help you. If you have any question, just come here in issues and ask me directly. Thank you for listening.
I've done it again, haven't I? Okay, next one's on. Let's see if we can get Daniel live here on the stream. There we go. Welcome, Daniel.
Hello, my name is Daniel, and today I'm going to talk about how we can overcome in-app purchase complexity with RevenueCat or Flutter applications. So first of all, let me introduce myself. I'm from Austria. I'm lead mobile developer at TechWise, and I'm in love with Flutter since version 1.0. Actually before version 1.0, but let's keep it simple. I'm here to help. I'm very active in the Flutter community. If you need any help, just reach out on Twitter and we can have a talk about any topic you want to talk about. And I'm not taking myself too serious, as you might have guessed by taking a look at my picture I provided to you. And I'm hosting the weekly Fluttered Arches Twitter space together with my friend Mengerdas, who is also talking at this wonderful Flutter event today. So good luck for your talk, Mengerdas. And I'm using way too many emojis, let's be honest. Man, that's obvious. First of all, let's start with the obvious question. What are in-app purchases? So in-app purchases are actually payments that get processed inside an application without redirecting to any other payment provider. So the payments get processed directly by the store or by the underlying payment service from both stores, from Google and Apple. And you can consider it as something like extra digital content for your application. Even though your application is free to download, there might be a lot of in-app purchases you can do or you can pay for that will give you additional features or additional content for your application. And I like to use my most favorite app, Headspace, as a reference here. If you choose a subscription here on the left page and click try free and subscribe, you actually get presented a dialog, a native dialog that says Google Play at the top, where all the subscription informations are listed and where you can choose the payment method in order to just click subscribe and process the payment. After that, you probably should have premium access to Headspace. And that's actually it. So there is a native SDK that provides you the dialog and the look and feel of the native payment, and you just call it, the payment gets processed by the store, and by certain mechanics, you get like you are like entitled to actually have premium access. And all the processed purchases, the purchased goods, even if it's a subscription or just an in-app purchase, get all connected to a Google account or to your Apple account that is actually processing the purchase through the SDK. And to prove that, just take a look into your subscriptions in the Play Store, and you will see all the subscriptions that are linked to your account. In my case, you can see my Google One subscription. So every transaction or every subscription or every in-app purchase gets linked to your account. And a lot of people often ask me, why not just use other payment providers like Stripe or something like that? We are familiar with Stripe, we know how it works. Why can't we just use this instead of in-app purchases? And that's a very good question, and I understand why a lot of people ask this. But the reason why is that Google and Apple charge 50 to 30% on each transaction that gets over the in-app purchase services. 15 to 30 because the amount of the fee, depends on how the purchase gets executed. If it's subscription, how much revenue you make with in-app purchases, and so on. So 15 to 30%, and that's actually the reason why they force you to use in-app purchases in order to stay in their store, because they make a lot of money with it, obviously. And we also have to keep in mind whether we buy or sell digital or physical goods inside our mobile application. Digital goods are stuff like additional features for our apps, subscriptions, in-app tokens, in-app money, stuff like that. Stuff you consume digitally. But physical goods are stuff like clothes, shoes, hotel rooms, or something like that. And you have, regarding to the terms of Apple and Google, you have to use in-app purchases for digital goods, but you can use other payment providers for physical goods. And that's why companies like Airbnb or Uber rely on different payment providers like Stripe, Braintree, or PayPal, because they are not selling digital goods, they are selling physical goods. So we know what in-app purchases are, but why are they so complex to implement? Why do I think, at least, and a lot of other people do think, they are so complex to implement? The first thing is that the documentation for, especially for the subscription APIs on iOS, are very not that good. And as a beginner, it's very hard to dive deeper into it. And if you have no idea how the documentation works and where you find certain information, it's very hard to become really, really good and to really understand what's going on. And that's a very big problem. And Tyler Hall actually has a very good quote on that. He said, half of Apple's documentation is online, the other half is only available in VVDC videos, and the other 90% is only available talking to an engineer in the lab, and that's very accurate, as I can speak out of my experience. The next reason why it's very complex to implement in-app purchases on your own is that you're not yet an expert. You have to consider there are two platforms that behave completely different from each other. They're completely different systems, and in order to really provide a very smooth subscription service, you really have to know what's going on. How does Google billing work? How does the App Store Connect payment system work? And that's actually where I think that we should let people that have more experience and build software around this issue do this for us and handle unexpected changes in the API or service outages or stuff like that. And that's actually what RevenueKit does for us. And that's why RevenueKit helps us a lot, but more on that in a minute. Error handling, not error handling itself, but like the fact that you really have to handle errors, because like nothing is worse than like payment system that doesn't work, because we're talking about money, right? Talking about money is sensitive, and do we have enough resources to handle system outages in our small team? We really have our servers up and running all the time, because there could come purchases 24/7. If our servers are down, maybe some transactions fail, we lose information, we lose subscription status, and that's why it's very, very hard to implement on your own and very, very like error prone. One false line of code and like the whole subscription service could like work completely differently. And that's actually pretty dangerous for your software. And while we search for errors that occur in the Google Play billing service or in the changed API or something like that, maybe others have already found that and fixed it, not just for them, but also for us, like RevenueKit does. And we're still talking about money. Money is a very sensitive topic. You don't want your customers to lose money. And otherwise, you really have to build up a support channel and like take care of the problems from your users. And we are often very scared of working with money when we're programming, because money is a hard topic, and where money starts, friendship ends, a lot of people say. And I guess that's true for in-app purchases as well. So yeah, and in 2020, when me and a few friends of mine started to build on a side project, which, disclaimer, we never really shipped, we also dove deeper into the whole in-app purchases stuff and how we can implement our own custom in-app purchasing flow. And we found that this is way too much effort for us in order to ship our application fast enough. I mean, we never really shipped it, but you know what I mean. And I got really frustrated, and I had no idea how to implement like the whole in-app purchasing flow and all the backend related subscription state updating stuff and kind of stuff like that. Until a friend of mine introduced me to RevenueKit. This friend of mine has a very, very successful app. We're talking about more than 2 million downloads together on Android and iOS. And he also implemented in-app purchases on his own, completely customly. And until it got too complex and until he wasted too much time on like taking care of native SDKs to update and stuff that broke and changed APIs and kind of stuff like that. So we also changed to RevenueKit. But what actually is RevenueKit now? You might ask. Like, it's considered a backend for in-app purchases. Let's say it that way. Like, RevenueKit makes an API that allows developers to add in-app purchases much faster and to wrap around Google and Apple subscription API service to make out of two different systems merge into one system that is like into one unified interface developers can work with in order to implement in-app purchases. And actually like takes away the heavy lifting from you and interacts with Google and Apple's APIs in order to verify transactions and fetch subscription status and stuff like that. And yeah, it makes the life of a developer a lot more easy and saves a lot of time, because you now just have one single source of truth instead of two completely different ones. Its main superpowers are actually managing all the purchases that happen inside your application from each user and managing the subscription status of each user. It is also useful for configuring products and the paywall and like the offerings the user actually see in a very intuitive way, and we will talk about that in a minute. And it gives you access to analytics and insight to grow your revenues, or to see how your revenues behave and how to scale your income. It introduces a feature called user identification, which is by far one of the coolest features in RevenueCAD, and we will talk about that later. And you will get a translation history for each user that actually purchased stuff in your application, which is also very handy for troubleshooting and support questions. And it provides a unified event notification. RevenueCAD makes out of two systems that behave completely differently, that give completely different subscription states, that verify transactions completely differently, one single source of truth. And to sum it up, RevenueCAD allows you to integrate a lot different applications into RevenueCAD. And there are three ways how you can use RevenueCAD in your project. The first one is just RevenueCAD, client-side only, no backend, no crazy subscription status stuff inside a database or stuff like that. You just have to restore subscription information if you for some reason delete the application or want subscription information on a different device. But otherwise, it's just RevenueCAD. You can use the analytics to like scale your business and stuff like that. The next way is to use RevenueCAD alongside your backend. Your backend lives alongside RevenueCAD. RevenueCAD takes care of all the purchasing stuff, and the backend receives information about subscriptions from each individual user via webhook or by calling the RevenueCAD API. And the last method is observer mode, which is like you already have your existing in-app purchasing world built up, and you place RevenueCAD alongside your implementation and connect it to your Google Play and Apple apps as like App Store Connect account, and like track all the information that are incoming regarding to in-app purchases. And in that way, you actually can access analytics and insights without using RevenueCAD inside your application, but just observing what's happening on the both payment sides. And I talked about the very intuitive product managing structure in RevenueCAD. And I want to go a little bit deeper into this so you can understand what's actually happening in RevenueCAD. So before we actually can manage products in RevenueCAD, we have to create the products in the stores. Since, remember, all purchases get processed by the store directly, we have to define in the stores how much money do we have, what is the name of the product, what is the unique identifier, and that's very important. We need this unique identifier to configure the product in RevenueCAD. In RevenueCAD, we configure, like we provide a one-to-one mapping to each product we defined in the stores for each platform. And this by just giving it the unique ID. And RevenueCAD needs this ID to actually track product transactions in the stores. So it's considered a one-to-one mapping. And each product gives the user a level of access. It entitles the user to do something in your application. And it's actually used to ensure that the user has access to content he paid for. And that's where entitlements come in. Entitlements are groupings of products that entitle, like that give the user this entitlement. For example, the gold monthly, the gold annually of both Google and Apple give the user the gold entitlement, and that's why we group those products into this gold entitlement structure. And this is actually the reason for its existence, is that we now just check whether the user has the gold entitlement and not if the user has purchased any monthly or annually gold product in the store. So it's a lot more easier to check whether the user has certain rights or not. RevenueCat packages are just group of equivalent products across different platforms. So you could, for a specific duration or for a completely custom term, let's say, we could create a package for all the monthly packages, for all the gold monthly packages, and put both the Android and the iOS monthly product into this package. We need this to actually put this into the offerings we provide to the user. And offerings are actually optional but recommended because they bring you a lot of features. And offerings are just selections of products that are offered to the user. It's actually the paywall the users see, and you can create different offerings and switch between them, which is pretty handy if you want to experiment with new products. For example, the default offering has the monthly package or the monthly product integrated, and the no monthly offering ditched the monthly product. And by switching to the no monthly product and letting it run for a certain amount of time, you can see how it affects the new users and how your revenue increases or decreases by just removing the monthly product from your paywall. And this allows you easily to switch between all different kinds of offerings, and it also allows you to offer special offerings for special type of users or special type of devices or application settings or stuff like that. And switching the current offering, like the default offering, immediately affects the user. So if you switch from the default, if you set the no monthly offering to the current offering instead of the default offering, all the users get affected, like only will see the no monthly offering in the future. So it affects the user immediately, to put it in a shorter way. So there was a lot of stuff I talked about. I hope you understood something, because now it's time to get rich. Kind of. So what we need to add RevenueCat to our application. First of all, we need a RevenueCat account. Super easy done. Sign up to RevenueCat, you have your account. Next is your Google Play console and your App Store Connect should be ready to add in-app purchases. You have to do a few steps in order to be allowed to allow in-app purchases for, let's say, App Store Connect, like agreeing to certain terms and adding text and billing information. But that's not part of this talk, and there is a great documentation on that on RevenueCat. The next thing we need are the service credentials for both Android and both Google Play Store and Apple Apps and App Store Connect. This allows RevenueCat to actually communicate with the both stores and fetch certain information that RevenueCat uses to build up transaction histories or subscription states or stuff like that. And we need to configure our RevenueCat products, entitlements, and offerings we covered in the last step. So intentionally, I wanted to cover this in my talk, but since I have not much time left, I won't be able to cover it. But we just need to know that we have, in our example, a premium entitlement we want our users to be able to pay for. And we need a little bit of time, since, especially for Android, because Google needs a little bit of time, up to 36 hours, to actually make the service credentials active. And otherwise you will receive an exception. I deal a lot with, that's what we need. And we jump right into PubSpec YAML and we add the purchases Flutter package. I provided the version so you can see which version I'm using currently for this talk. And that's actually the RevenueCat package. It's a wrapper around the native in-app purchases SDKs, and it's responsible for communicating with our RevenueCat instance. The next thing we are going to do is to set up the connection between our application and our RevenueCat account. Therefore, I'm going to do this inside the main. Normally, you should do this inside the launch, inside some kind of launch view, which executes after you run the app. But for now, I'm going to do this inside the main. If we are doing this before run app gets executed, we have to call widgets flutter binding.ensure initialized, otherwise the application will crash. We also have the ability to set RevenueCat debug logs to enabled, and this will allow you to log certain transaction information and purchasing information inside the logs automatically by RevenueCat. And the next step is to check which platform we are at and to call purchases.setup with the platform specific public key we are able to generate inside the RevenueCat platform. So keep in mind, if you're on Android, you call setup with the Google or with the RevenueCat, like the Android public key, and if we're on iOS, we call it with the iOS public key. And I provide those keys via Dart define to my application, so I don't have to hard-codedly add it to my code. And the first thing we are going to do is to check whether the user already has the premium entitlement, and therefore I'm going to create a very simple home view with a scaffold and a center and a future builder, which is responsible for fetching the purchaser information from RevenueCat about the current user that is using the application, which is linked to the Google or Apple ID, and fetch all the information we have about this purchaser. This is as simple as just calling purchases.get purchaser information, which gives us an instance of purchaser info. And there are all the entitlement information, all the stuff related to the purchaser contained in. Once the future finished, we get the purchaser info from the snapshot data, and we check, or we try to get the premium subscriptions by calling entitlements.all with the name of the entitlement we actually want to get. And this could be null. If the user not yet has the entitlement, then we are going to check whether the premium entitlement is null. And if it's not null and it is active, then we show that to the user that he's subscribed and he's awesome, and give it a little bit appreciation for the support he gives to us. And otherwise, we are going to show the product list. And we could do this actually a little bit more different. We could also just check whether there is any active entitlement available, because we only have one entitlement, which is the premium entitlement, and we doesn't care about the others. So we could also do this. And in the product list, we are just going to fetch all the packages that are available in the current offering. And we do this with a future builder. And if you want to handle all this stuff, all the fetching, all the interaction with purchases in a state management method, feel free to do it. I'm doing it in a future builder, and I keep it very simple so you also can understand what I'm doing. So we fetch all packages we fetch all offerings by just calling purchases.get offerings, and we receive an instance of offerings which has all the offering related information contained that we can configure inside RevenueCat. And with .current, we get the offering that we marked as current inside our RevenueCat account. We could also do this a little bit more different. For example, if we have the current logged in user as a special user, we can get the special offering for this user. Or if the user has a specific role, we can get offering for a specific role. Or if the Android version of the device is below 10, we can get a specific offering for all users with Android versions below 10. You can actually get each offering that is configured inside RevenueCat. And for now, we just use the current one, which we decided to be we just use the current one. And if the offering is null, we are going to return an empty list. And otherwise, we return all available packages of this offering. Remember, a package is just a group of products. Of products for each platform. And the data we receive from the future builder, we check whether the packages are empty. If the packages are empty, we just show the user that there is nothing to subscribe to. And otherwise, we build a list of product items, we pass our package into each product item. Remember, here we are going to access each package via index. And in the product item, as previously already seen, we receive the package. And by calling package.product, we receive the product of the package for the current platform. So if you're on Android, we receive the Android product. If you're on iOS, we receive the iOS product by simply calling package.product. Because a package has multiple products, yeah, that's it. And we receive the string by calling product.title. We receive the title by calling product.title, and the price string by calling product.price string. The price string is, and those are two values that are actually configured inside the App Store or Play Store. And the price string is very handy because it's actually the price formatted with the currency of the user. Then we can show our product information however we want, wrap it in a gesture detector to allow the user to start the payment process if he clicks the product item. And then if the user clicks on the product item, we call purchase product. And what we are going to do here is to just call purchases the purchase package and pass the package of the product item into it. And this will result in opening the inner purchasing dialog. You can choose the payment method and the payment processes, and you receive all the freshly updated purchase information. And here we can again check whether the old premium, whether the premium entitlement is available. If it's available, we are considered as subscribed, and we do any further actions like fetch, like telling our backend to fetch the new subscription status, or routing to a different route, to a success route, or showing a snack bar, stuff like that. So yeah. And now I'm going to talk about the last thing, the user identification. And that's a feature that is very useful, especially if you deal with a custom backend. So consider you have a login and you call a login service with an email and a password, and you receive the user from it that is actually logged in. RevenueCat gives you the possibility to connect all the purchases that are going to happen to a specific ID. Normally, all the purchases and transactions are linked to a random RevenueCat ID, but you can say by calling purchases.login with a specific ID that all these informations are linked to this ID now. And now you can use the ID of the user from your system, from your database. And this allows you to actually fetch user-specific subscription information from your backend by just providing the ID to RevenueCat, or by getting webhook information and checking which user this information is connected to. This is very handy. And now you can do stuff like paying the subscription on an Android device, logging out, logging into an iOS device, and also is subscribed, because the subscription is no longer directly connected to the Google Play account, but to actually the user from our database by the ID we gave it. So that's very handy, and that's a very useful feature which I really like and which saved a lot of time for me. So, and that's actually my talk for today. I had way too less time. I would like to talk a lot more about this topic, but I will stop this talk with a very simple quote from a very wise man, Mr. Krabs. Remember, time is money, and if you're wasting time, then you're wasting money. And that's really true. We saw how easy it is to integrate in-app purchases in a matter of hours instead of weeks, and that's actually the goal of RevenueCat. And that's it for me. Thank you for watching, and I see you the next time.
Thank you, Daniel. I do like that. If you're wasting time, you're wasting money. So we've got, we'll go straight to the next one. We've only got 1 minute spare, so let's see where we go. So we have Madura, I can't say her name, Madura, talking about geolocator in Flutter. Let's go.
Hello everyone. First of all, thank you so much Flutter Developer Group London and Flutter Festival London for giving me this opportunity to share my talk and my work which I have implemented some functionalities in Flutter. A bit about me. Myself, Madhura Sanjay Deshmukh. I am a BCA graduate and presently pursuing MCA. I am from India. I am a Flutter developer and a part of Tech Power Girls community. I do conduct beginner level workshops for Flutter developer beginners with the Tech Power Girls community. What is geolocation? The question arises in each and everyone's mind. What is geolocation? In simple words, how does the geolocator works? The geolocator it collects its data from the GPS on a device and cellular networks. Basically, it is the identification or estimation of the real world geographic location of a mobile phone or a computer. In Flutter, geolocation is the process of identifying a user's current physical location when they are interacting with an application. Basically, the question also arises what is geolocation and GPS? Though the geolocation provides the location of device but is generally used in a variety of applications to help locate human users. Geolocation works through a pre-built GPS in a device that propagates the device's longitudinal and latitudinal coordinates. In Flutter, the geolocator plugin has or it gives the output into the coordinates and those coordinates are longitude and latitude. The longitude and latitude are the system lines to the earth which are used to describe the location of any place on earth. The lines which are in the east and west are the latitude and the lines which are in the direction of north and south the lines are of the longitude. Though in Flutter there are some features of geolocator. If we use the geolocator, we get the last location, we get the current location of the devices. Also, we can check the location service are enabled on the devices. We can calculate the distance between the two geo coordinates. In Flutter, if we use a single geolocator plugin, as I said earlier, it gives the output into the coordinates, which are the longitude and latitude. The geolocation plugin is the simplest way to get and track a user's location without any hassle. So, for implementing the geolocation into our Flutter, we have to add the plugins and also we do need some requirements into the Android as well as into the iOS. But I have implemented this geolocator with the Firebase. But we'll first go with the code. Into the Android Studio or in the VS Code which we are using, we have set the location accuracy depending on the accuracy we need. And we can also set the accuracy time interval between updates whether we want to force usage of Android Location Manager. Here, in the snippet code, I have declared the three variables. The first variable is location message, and the other two are latitude and longitude, where we can set the accuracy depending on the accuracy we need. Basically, the location accuracy is been set here. Next, to connecting with the Firebase. Before connection, we need to implement the connecting steps to the Firebase with Android Studio or with the VS Code. Then we can move further to the code. We have connected a collection from the Firebase, which is known as geolocator. Then we have mapped fields like latitude and longitude from the Firebase. As we can see, a Firebase structure. Here we have the collection of geolocator and the field of geolocator which contains the latitude and longitude. Here I have tried many times, so I have got the different values of longitude and latitude, and those values are stored at the Firebase, which will never be get deleted, which will be stored at the, or I'll have the record at my Firebase, which is our database. So if we use the plugin and the code with some of the UI or some of the beautification, we can make a simple basic app of geolocator, which we can get the output only of the coordinates. We can get the latitude and longitude of our current location. Here we can see, if we play, we are getting the permission to access our location, and then we are getting the latitude and longitude of the current position. So we are clear about how to get the coordinate points. But if we, or if a user need a address, we have to know how to convert these coordinates into a string of addresses. For this, in Flutter, we have a plugin of Geocoder. In Flutter, geocoding plugin, which provides easy geocoding and reverse geocoding features, which means if we have the coordinates, we can convert them into the address, or vice versa, if we have address, we can convert them into a longitude or into the latitude, or basically into the coordinates. It is the essentially process of getting physical map coordinates and detail for an address, or we can also get the details of a place from the coordinates. Basically, in a simple words, we can call a geocoder or translator or converter of the coordinates into the address. Same as the geolocator, we need the plugin for the geocoder, and we have to add it into a pubspec.yaml file. Also, the requirements of Android and iOS are same for the geocoder, which are for the geolocator. Here, we can also get the updated dependencies at pub.dev site. After that, we can get the detailed information about user's current location using geocoding Flutter plugin as shown. Here we get the longitude and latitude variables into a string of which is resulted into the address. As I said earlier, we can get the coordinates into the address as well as the address into the coordinates. Here, in the first snippet, we can get the details of a place from the coordinates, and into the second, it's just getting a physical map coordinates and details for an address. While implementing all the code with some of the add-on UI code, we can get the output like this. Here we are getting the location. After getting location, we are getting the coordinates, and those are converted into the address of the current position. So basically, now we have come through about two plugins, which is Geolocator and a Geocoder. While using only these two plugins, we can build a basic location app with the geolocation or geolocator. We can get the coordinates of the current position or current location, and we can convert those coordinates into an address string while using the geocoder plugin. Now we have got the coordinates and the address. But if we need to map the address or to find the another destination from our current location, there is the functionality of maps in Flutter. In Flutter, a plugin that provides a Google Map widgets. Here, as it is said with the Google Map Flutter plugin, we can add maps based on Google Maps data to our application. which handles the access to the Google Maps servers and displays the maps. Basically, we all know how to use a map. We uses a map, but we in Flutter, but we can see how to implement a map. Here, if we uses a map into the Flutter, we have to add dependency into a pubspec.yaml file. The dependency is Google Map Flutter. We can also get the updated plugin at the flutter.pub.dev site also. And while after getting the plugin, we also have to add some requirements for Android as well as iOS. It's just that we just need to take some permissions for the location access. Now, here are the two codes or the small snippets of codes which are of the adding the Google Map widget. Here, in the first snippet, we have defined the callback for the completion of creating the map, created the map's initial camera position, and into the second snippet, we have included the Google Map widget as the body of our scaffold widget. We have set the initial camera position, we have set the map type to the normal, and added a callback listen for the creation of the map widget. If we done this, we can, as it is said that we have get the Google Map as the structure of our body. Though the Google Map widget is the structure or a scaffold of our body, then we generally we come to see this location icon into a map. So what is this? In Flutter, it's basically a map marker for search results. Into a map, if we search any address, we got the address with pointed this icon on it. So this is basically a syntax of that map marker, where we have a marker which has the marker ID, the position, and the places, which we can insert the static also, or we can go through the dynamic also, as the data is coming from our geolocator to the geocoder, and which is then converted into the map. So using these three plugins or functionalities, we can build a simple map or a simple location app in Flutter. If we implement the map code, we get the output like this. We can zoom it or zoom out also, as we can all see. It's a static address. We get the latitude, longitude, and after tabbing the get location, we are getting the map. So as I earlier said, if we use these three plugins, which are Geolocator, Geocoder, and Google Map Flutter in our Flutter app, we can basically build a simple location app using these three plugins. Not only these three plugins, we have many plugins related to geolocation, maps, geocoder, location pin, map launcher, etc., from which we can easily build any location app. The fluttergems.dev geolocation maps. This website has many numbers of plugins related to the location app. Some of are, the first is map launcher. Here in the first output it is a map launcher, and the second output it is the navigator in the map launcher. We can see here we have get the basic map is launched after putting address, and here we are getting, or it takes us to it's navigate to our address. Here the animating location pin we can use to make, or it's beautify the app, or it makes the user to take the interest in a app. There are some apps, popular location based apps like Google Maps, Uber, Pokemon Go, TripAdvisor, weather app, shopping app, or we can say e-commerce app, dating apps. Basically dating apps, we want if we are booked a date, didn't know the destination, we didn't know the address, the apps provides the location to the us so we can reach to the address. Google Maps, the Uber and the Ola are widely in use. Basically WhatsApp, the chat app is also is using the Google Maps or the location functionalities. Not only WhatsApp, the social media sites like Facebook, Instagram are also uses the functionality of maps. Also some of the apps like gaming app, travel app, weather app, navigation, health and fitness, dating. For the health and fitness, if we have tracked a goal or we have set a goal of walking of 5,000 steps, but we didn't know the location or the addresses. So while using the fitness app or health app, we can count the steps as well as we can count the distance with the coordinates from which we have started and from which we have ended. So for health matters or to the health department, these functionalities are also in demand nowadays. Basically, if an issue arises, our device or our phone is lost, we can find our phone while uh, while getting the location or while checking the location of our phone, because each and every ask our device the permission to access its current location. If somehow we have lost our device, we can find it by using the location or the coordinates or the map. Apps we can build with Flutter using geolocator, geocoder, and maps are food ordering, food delivery apps like Zomato, Swiggy, also like Uber and Ola. So there are n numbers of apps which uses the location functionalities. We can easily implement them into a Flutter and we can build our own app. Also we can add it on to our Firebase, which will have our database, and we can make a beautiful app of many changes also we can make. So using these functionalities, these plugins, we can make a basic location app. So that's all about the geolocation in Flutter. You can connect with me to the LinkedIn, Twitter, GitHub. Thank you.
Thank you. That was very enlightening. I've done quite a bit of location before, and you never really think about it sometimes. Good information. Thank you for the share. So we've got another few minutes, another 10 minutes at 15:30 before we have our next speaker. And I can never remember how you pronounce his name. Miglas? Something like that. I'm probably saying it completely wrong, and he's going to tell me right off. But yeah, he'll be up next. So let's go and hold for a bit. And here we go again. I think I've been taught how to say Maglias. I think I've got that right. We'll find out. And here he is to talk us through. Hang on. Oops. Here he is to talk us through patterns and all the not so obvious patterns. Maglias, take it away.
Labas, my name is Maingirdas, and today I'll share a few interesting ideas about design patterns in Flutter context. First of all, I will briefly introduce the main idea of design patterns in object-oriented programming. I will also demonstrate the example app, and finally, we will investigate the following design patterns and how they were used to achieve the final result. Before diving deeper into design patterns, a little bit about me. I am a software engineer from Lithuania. I am currently a mobile tech lead at Billow, where using Flutter happily is my day-to-day business. I'm also a Google developer expert for Flutter and Dart technologies, and also I'm an organizer at Flutter Lithuania. I'm using Flutter since its beta version, so I think I have some experience to share something interesting with you all. Now moving to the main topic, let's start with some general information about OOP design patterns. First of all, what is a design pattern? In a short form, design pattern is a typical solution to a common problem in software design, and you shouldn't mix that with UI design. A design pattern names, abstracts, and identifies the key aspects of a common design structure that make it useful for creating a reusable object-oriented design. Design patterns in general gained their popularity after this book of Gang of Four was published in 1994. You won't be able to copy-paste the complete solution from this book. However, you could learn how to structure code properly to avoid some basic object-oriented code design pitfalls. By following these ideas, you could speed up the development process and also improve code flexibility and reusability. The example app I want to show you is Patternify. It's a simple music playlist management app which name was not influenced by any other music streaming platform in any way. Even though the application is very straightforward, I've used block state management just to show you how well any state management solution could be integrated with other design patterns. Also, for the dependency injection, I'm using provider since this package is already a dependency by the Flutter Bloc package. I can show you the demo first. So here's the example Patternify app. The app consists of two tabs, the library tab as well as the playlist tab, which is currently empty. So the library tab contains music collections. Each music collection consists of other collections or standalone songs, so you could access the music collections infinite level deep. If you want to add a song to your playlist, you could tap on the star icon. Also, you could tap on the star icon again to remove the song from the playlist. Also, as you may notice at the top right corner in the application bar, the arrow appears which undoes the previous operation. So yeah, it undoes all the operations. So let's move to other collection and add some songs to our playlist. Now, if we move back to the playlist, you could see that all the added songs are there. If you want to, you could reorder the songs in the playlist by drag and dropping them. Also, the reorder operations could be undone, as well as the previously executed add song operations. Lastly, inside the library tab, you could see that we have a settings gear in the application bar. And by accessing the settings page, you could switch whether you want to use the Cupertino or material widgets. So let's say we turn the using Cupertino widgets option off. And as you may notice, the switcher has changed to the material one, the application bar has changed, as well as the bottom navigation bar, and also the loader, which is not visible there on the screen. So yeah, so that's the example Patternify app. So the first design pattern I want to talk about is abstract factory. The official definition from the Gang of Four book of the abstract factory is provided in the slide, but in general the pattern is very straightforward. So we abstract the process of objects creation and to be more specific, a family of objects or just somehow related objects, and we abstract that by encapsulating the code into separate factory object which follows the common interface. Abstract factory is a creational design pattern since its main purpose, well, is to create objects. First of all, we declare a common interface for objects creation, which is named as the abstract factory. Then we create specific factories which implement operations defined in the interface. Each concrete factory corresponds only to a single variant of products, or you could say only to a single family of related objects. We need to define an interface for a type of a product object, which in Flutter case could be a stateless or a stateful widget. Finally, the concrete product is just a specific implementation of the component you want to create. To implement the design pattern, first of all, we define an abstract factory interface, or in Dart programming language case, an abstract class. And in this interface, we define methods that should be implemented by all the specific factories. As you could see in this interface, we define methods to create the application bar, to create the bottom navigation bar, loader, page router, and also a switcher. As you could notice in the example app, we have two types of widgets, so these are either material widgets or Cupertino widgets. Thus, we create two concrete factories, and one factory, the material widgets factory, is responsible to only create the material widgets, while the other Cupertino widgets factory is responsible to create Cupertino widgets. As you could notice, these both factories implement the defined methods in the abstract factory interface. Next, we implement the specific components or widgets which are created inside the factories. As you may recall from the abstract factory design pattern definition, we need to implement the product interface. So for the interface itself, we are just using the stateless widget, which is a common interface for both material and Cupertino widgets. So on the left, there's the specific implementation for material switcher and material loader. While on the right, you could see the specific implementation for the Cupertino switcher and also for the Cupertino loader. After implementing all the specific factories and components, it's important to use the right factory in your application. Inside the root component of the app, there is a method which creates the specific factory based on the current platform the app is running. After the specific factory is created, we inject it using provider, so it could be resolved from the widget tree in any place of the app. Finally, when we need to create specific component, we just simply resolve the injected factory and use its methods to create components. Important thing to notice here is that we only use the interface to resolve the factory and later use its methods. Hence, the code does not really care about the specific implementation details, whether we want to create material or Cupertino widgets. The injected factory takes care of that. Okay, we have our widgets as separate components. Now we need somehow to glue them together. For this task, we will use the composite design pattern. So the official definition of the composite design pattern is visible on the slide, but when we talk about the composite design pattern, we talk about the tree data structure. And a good example of that is, well, a Flutter widget tree, where widgets could have child or children property. Thus, we are able to create a whole app composed of separate widgets as a single tree structure. The main idea of this pattern is to define a common interface that uniformly represents both leaf and composite nodes. So the leaf node is a node that does not have any children, and the composite node is a node which have one or more children. And by defining a common interface for both of these nodes, we are letting our code to treat every element of the tree structure in the same manner. Composite is a structural design pattern since it defines the structure of the code. We define a common interface for objects in the composition and then define two kinds of components, leaf and composite ones. Leaf nodes, well, as I already mentioned, does not have sub-elements or child components, so it defines behavior for primitive objects in the composition and actually does most of the real work since they don't have anyone to delegate this work to. Differently from the leaf components, composite objects stores children elements and delegates the work to them, while the children processes intermediate results and then returns the final result to the client. To implement the composite design pattern, first of all, we define a common interface for both leaf and composite nodes to follow. In our case, we define a music library item abstract class that defines methods to get the count of objects in this structure, also get the total duration of this music library, and also define a method to build the actual component. Then we implement the defined methods in our leaf node and our composite node. The leaf node just simply implements those methods, since without having any children, you cannot really delegate the work to. On the other hand, the composite node contains a list of items of the music library item interface, and this allows us to put other composite nodes together with leaf nodes, hence building the tree structure, and also delegating the work to leaf nodes. In addition to this, leaf and composite nodes also extend the stateless widget, and this allows us to build these components as a standalone widgets if we want to. This provided code is not really related to the design pattern itself, but this is how we build the tree data structure that is later used in our example app. So first of all, we retrieve the required information for the music library, so that's music collections and songs, and then we build the whole composition. So first of all, we put every single collection into the map, which is used as a lookup table. Then inside the for loop, we go through each of the collection item and check whether it contains a parent ID. And if that's yes, it means that this collection belongs to the other collection. So we just simply assign it. Then the whole tree structure is there. We just simply add the songs to the corresponding collections. And lastly, we return a list of top level collections. So we have our music library that is visible in our example app's UI. Okay, we have our composition. Now it's time to render it. And in fact, it's very straightforward. We just go through the list of music library items and we call the build method on them. We do not really care whether this specific item is a leaf node or the composite node. We just simply use the unified build method from the interface. And that's the beauty of the composite design pattern, since we do not really care if we need to render just a simple leaf node or we need to render a complex composite node. We just call the unified method on them and the rendering is just working. Also, if we want to render the leaf or composite nodes as a standalone widgets, there's no restriction to that. They both extend the stateless widget, so yeah, we just could use them straight away. Well, with the previous two design patterns, we implemented the whole structure and UI of the app. Now, it's time to add some interactivity to it, so here goes the command design pattern. The official command design pattern definition is provided on the slide, but in simple words, command is just a unit of work or a request extracted to a separate class object which contains all the required data to execute the operation. Since we have all the needed information inside the class, the request is completely decoupled from the sender, and that brings a lot of benefits. So first of all, we can queue several commands and execute them at once. We can delay them, we can change the order of the commands, we can undo the last operation, etc. Differently from the previous two design patterns, command is a behavioral design pattern since it defines how different components interact with each other, meaning it defines the behavior between them. To implement this design pattern, the common command interface is defined and later concrete commands are created so to implement the specific execution logic. Then the invoker triggers the command instead of sending the request directly to the receiver. So it means that the client code does not operate on the state directly. For that, a standalone, separate commands are used. Then the receiver knows how to perform the operation, and the receiver is just an object on which we want to operate. So usually the receiver contains the state we want to mutate. In the example app, we have three different operations or three different commands that are applied on the playlist. So that's add or remove song to or from a playlist, and also change the order of songs in it. For the playlist commands, we define a common interface to execute and undo the command. Then we have a base command class that stores our receiver as well as backup list of songs. And this backup is stored once we initialize the command, and we just simply copy the current songs list. In our case, the receiver is a playlist class. This class contains a state which we want to mutate, and that's a list of songs. So by using commands, we want to add or remove songs from the list, and also change the order of the songs inside the list. As I already mentioned, our example app has three different commands. So that's add a song to the playlist, remove the song from the playlist, or reorder songs inside the playlist. As you may notice, each of these commands implement the execute method defined in the playlist command interface, and each of these commands contain all the required data to execute the operation. Now, when we want to somehow operate on the songs in the playlist, instead of mutating the state directly, we create a command instance for that and pass the command to the qubit class. For those who are not familiar with the concept of a qubit, it is a part of the Flutter Bloc package, and it is a simplified version of Bloc class, where we call the functions directly instead of sending events to the block. As you can see, before executing the command, we store it in the command history stack, so we could use this when we want to undo the operation later on. And also, I want you to notice that we have only one method for all the different playlist commands to execute. Since they follow the same interface, we just simply call the execute method on them and do not worry about the implementation details. It's quite similar for the undo operation, only we don't need a separate command for that. We call the undo last command method on the qubit. Then inside the qubit, we pick the last command from the stack and just trigger the undo method. And again, we don't care about any details on how to do that. The command takes care of all the details by itself. So that's it about the command design pattern, and the last one I want to talk about is memento. The official definition of the memento design pattern is provided on the slide. When we implemented the specific commands, we just simply stored the list of songs as our backup option. However, technically we could mutate the backup state from inside the command class because, it's just a simple list and we know its methods. Thus, we will use the memento to encapsulate and protect our backup state. So the memento design pattern lets you save and restore the previous state of an object, and that's called a snapshot, without revealing the details of the implementation. The same as command design pattern, memento is also a behavioral one, and I would say a very tricky one as well. So here are the responsibilities of each class in this design pattern. So memento interface restricts access to the concrete mementos fields, and it only declares methods related to mementos metadata. Then the concrete memento stores originator's internal state and also protects against access by objects other than the originator which has created it. The caretaker only keeps the memento but never operates or examines its data. Originator creates a concrete memento containing a snapshot of its current internal state. It also provides the restore method to restore the internal state using the concrete memento. So to sum up, originator creates the snapshot of the current state, which is stored by the caretaker. Later, when we want to restore the state, once again we use the originator for that. Nor caretaker nor any other class has an access to the backup. So the state is completely encapsulated and it cannot be accessed from the outside. Even though the memento design pattern seems very complex, actually all the implementation details are visible in this slide. So first of all, we define the memento interface, which only allows to get the state but not to operate on it. Then we implement a specific memento, which stores the backup of a playlist state. And then originator class takes care of the memento's creation and implements the restore method, which retrieves the playlist backup from the memento object. So for our case, the caretaker is the command itself. Previously, we stored the backup list of songs inside the command, which could be mutated directly, but now the command cannot mutate the backup directly in any way. During the initialization of the command, the memento or the backup is created by originator. When we want to undo the operation and restore the backup, again, the command does not change anything. Originator takes care of that. And command execution itself is pretty similar, but this time we pass the originator object instead of the backup directly to the command. So this is the comparison of our abstract command class without and with a memento. So without the memento design pattern, we just simply store the state and our backup directly. So when we wanted to mutate the state or undo the operation, we just mutated the state directly from inside the command. By using memento, we encapsulated the state inside our originator and memento classes, so the playlist command does not know any details about the state. It just executes the originator restore method in case of undo operation, and also when we create the command, the backup is also created by using the originator method. It is exactly the same with the concrete command class. If we compare the memento implementation with the previous command implementation, you could notice that now the state is not mutated directly in any way as it was done before. Hence, we separated the concerns and reduced the risk of negatively affect our backup state. That's all the design patterns for this talk. The presentation slides as well as the example app could be found on GitHub. Also, if the design patterns topic seemed interesting to you, do not hesitate to visit my Medium profile, where I wrote an article about each design pattern described in the Gang of 4 book. And finally, I created an interactive library of design patterns under flutterdesignpatterns.com, so you could inspect each design pattern, check the interactive example, and learn more about each of them. That's it from me. Save trees, stay solid, thank you, and see you around.
Save the trees. I like that. Gang of Four book. I have the Gang of Four book. It's really good, actually. It's the book that was shown, the design patterns book. It's called the Gang of Four book, and I think it's kind of I can't remember its first published, like 1970. It's got a language all of its own. It talks about messaging, which is the communication between classes. So take it with a just sort if you read it, but there's some more modern versions around. So we have 10 minutes before our next talk, and after that talk, we'll do a wrap up with everyone else here on track 1. So stick around, and Roa is going to join us. Welcome back. So we're about to start Ra's talk on the Flutter API integration with caching. Before we get going on that, then I think it's worth mentioning that stick around because we'll have a little tidy up and last minute closing, and we'll get everyone else on here as well. So see you soon.
My name is Ra. I've been a Flutter developer for almost 3 years, and I'm very happy and excited to be here with you to share how you can integrate a REST API into your Flutter application with caching so you can add offline support to your app for a better user experience. We will implement this using various packages and design patterns. We are going to use Hive for local storage and Dio as an HTTP client, and we're going to use them by implementing the service locator pattern, and we're going to make requests to the API using the repository pattern. And we're also going to implement this in the UI in a way that can be reusable easily and efficiently. Let's see the application that we're going to learn how to implement in this session. It's basically a Flutter articles directory where you can see articles, open each article, and pressing on the avatar of the author displays the list of articles of this author. This is achieved by using the REST API of the dev.to platform. You can find link to the documentation of this API in the README in the repository of this application's code. Before we get into coding, let's have a look at the user flow. So here I open the application for the first time on my phone. And you can see from the log that I got a network response. So I got the data from the network. I'm going to browse, and I'm going to open multiple articles for the first time. Now I'm going to pull and refresh the data. We'll see here that we got the response from the network as well, because we want the user to be able to get the latest data when they pull to refresh. Now, when we visit an article that we visited before, we're going to see that the response came from cache. So we can see that the article loads instantly when I open it without the need for a new network request, like this one. So it's instantly there. And when I pull to refresh, I can get the response from the network. Now, let's try and turn off the wireless. I'm going to open the articles that I opened before, and they still open perfectly, and the data is still there, and I can browse and read them. However, what if the user wants to pull to refresh? Is it going to get the data from the network and throw an error because we have no network connection? It's going to show that an error occurred because of no network connection, and the response got received from cache as well. This article I opened before, so when I pull to refresh, it says that I'm offline as well. When I tap, it refreshes, but it's still getting the error. Let's turn it back on, and I'm going to tap on the green bar you see at the top, and it's going to get the updated data. Everything works perfectly. Let's see this in the user flow diagram. When I'm on first visit, or when I pull to refresh, I make a network call. If the user has internet connection, the data is returned normally from the network. If the user doesn't have a network connection, and the data is cached from before, this happens with the pull to refresh, then it returns the cached data. If it's not cached before, it returns an exception. On second visits, the data is retrieved from cache directly. So the way that we're going to go over the code is first, we're going to go over the domain and data layers, meaning the infrastructure, the services, and models. The services used in this application are going to be a storage service for caching and an HTTP service using Dio for the HTTP client. We will also set up the models and the article repository that will make the API call. And then we're going to go over the UI implementation and see what widgets and pages are there and how an HTTP page wrapper is created which is basically a widget that takes care of all the fetching functionality for us in the UI. So it fetches the data, refreshes it when we pull to refresh, and also shows the offline banner and allow to refresh when we tap on it. And we're going to see how the offline banner was implemented. We're going to start with our services. So basically we have two services, and we have a service locator file that helps us locate those services. Each service has an abstract class and an implementation. Let's first take a look at the abstract storage service class. It's basically a boilerplate that the storage service implementation is going to follow. It initializes the service, removes values, retrieves values from the storage, clears it, checks if a key value is present in the storage, and sets values as well as terminates or closes the storage, like if closing a database or, in our case, closing the Hive box. Now, let's see the implementation. We simply, for example, the init function is implemented by initializing Hive and opening the box, and each other method is implemented with its Hive implementation accordingly. Now let's take a look at our HTTP service abstract class. It has a base URL, headers, basic functionalities like getting data from, like the get method, the post method, and the put and delete methods. We also have here private functions that are used inside the get method to implement caching. We can't implement these methods directly, so we're adding this annotation to annotate that we're only going to use them in testing. Otherwise, they're implemented inside this get method. Now let's see how we implemented this HTTP service using the DO package. We simply have here a dependency on the storage service because we're going to cache the network calls inside the local storage, and we have a getter for DO that should also be only visible for testing, the implementation of our base URL, which is the URL for the dev2 API, as well as the headers implementation, and the base options that we use inside the get from network function that we're going to see shortly. And this is the implementation of our get method. And this is where all the functionality is happening. Basically, we have here a force refresh flag that is set to true when a pull to refresh or the refresh from the offline banner. And we get from cache, we build the storage key based on the endpoint and the query parameters and the request type, which is only get in our use case. And we see if it exists in storage, get it, convert it into a model that is cached response, which stores the age of the cache and has a getter is valid that allows us to determine whether the age of the cache has passed or not, which we define, and we check if that cache is valid, then return the response data of that cache. If a cached response is returned and the force refresh flag is not true, then we're going to return this cached response. However, if all of that doesn't get called, then we're going to try to run a network call. In this network call, we are going to do a DO get request, and if the data is null or if the status code is not 200, then we're going to throw an HTTP exception. Now, if the data is not null, then we're going to create the storage key based on the input of the request, and we're going to create the cached response and store it in storage. And we're going to return the value from this network call. Now, in the case of a force refresh equals true, it's not going to go through here, and it's going to try the request anyway. But what if an error was thrown due to not having internet connection? Well, in this case, we're going to check if we have a cached response from before, then we're going to send it back to the client with a flag is offline equals true. This will help us display the offline banner, and we're going to look into it later. If all fails, there are no cached response and no internet connection, then we're going to throw an error. But this will be our last resort. Now let's see how we use these services that we created with getit and the service locator pattern. We simply initialized a getit instance and registered singletons for the storage service and the HTTP service. We have to register the storage service first because we have to use it in the DO HTTP service. I added here a function that resets the service locator, and it's used for testing purposes. We call this setup service locator in our main function in main.dart, call the services, initialize the storage service at first because we want it to be ready and the Hive box opened, and we're going to use the HTTP service inside the app widget, and we're going to see why in a minute. Now we're going to set up our article repository to get articles from the REST API. To do so, we're going to set up our models. So what I did here is simply go to the documentation of the API and see the structure of the responses of the endpoints that I wanted to implement, which are articles, as well as a published article by ID, which contains, most importantly, the body HTML and the body markdown. And then I created the models accordingly. I made my models extend the equatable class using the equatable package because this is helpful for testing reasons. Now, after creating my article and author models and implementing from JSON methods for them so that I can use the raw data, I created the article repository. We also have an abstract class for our repository, and we implemented this repository and named it HTTP article repository. It has a dependency on the HTTP service, of course, because it's going to do GET requests, as well as implementation for the GET articles request, which receives a list of articles, and the GET article request, which receives one article based on its ID. Now, the GET articles implementation is simple. I'm here adding the query parameters, username or tag, and simply calling the request. Now, as we remember, our HTTP response contains the isOffline boolean. And here, I'm using my repository with a change notifier so that I can change a value, like I'm doing here with the isOffline parameter, and notify listeners so that I can update the UI accordingly. And we'll see how we implemented that later. Here, I'm simply returning the list of articles, and here, I'm also returning an article as well. Now we're going to see how all of that is implemented in the UI. In our app widget, we're wrapping our material app with a multi-provider using the provider package and the change notifier provider with the value of our HTTP article repository. And we're giving it the HTTP service dependency. And then we have our homepage. Generally, API requests are made inside stateful widgets using the Future Builder. However, personally, I like to use the Stream Builder because it gives me the ability to refresh the content easily and more efficiently. Generally, I use a Stream Builder and give it a stream controller with the type of the content that I'm going to populate it with. And on init state, I'm assigning my article repository to a provider. Don't forget to set listen to false because we're in the init state, otherwise our provider will throw an error. And we're not listening to any values right here. We're only using this as a pure repository here for the GET requests. And then I call the GET articles, which populates the stream controller, adds data to it, and on error adds an error to it. And then I wrap my stream builder with a refresh indicator that calls the same function on refresh, which in turn updates the stream controller. Now, in the builder of my stream builder, I can check for error, for loading state, and then for a finish state. Generally, I like to not only check for data, I like to check if the data is a list, I like to check that it's not empty as well. Otherwise, it will display no data. If I have data, then I'm going to display the articles list that you see in the homepage. Otherwise, also show no data. This structure, instead of repeating it over and over again for every page that has an API request inside it, I created an HTTP page wrapper widget that does all this work for me. It takes on a type, a data request function, and custom widgets for error, loading, and no data, as well as the content builder. I'm applying the same logic here using the type that I'm going to provide to my widget, and I'm also including the refresh indicator with a call to the getData function with a force refresh true, so that it forces a cache refresh if we have internet connection, of course. And I'm handling all the logic of the state of the snapshot. I'm only returning the content if there is data. We're going to talk about the offline banner in a minute. Let's see how this HTTP page wrapper is used in our clean home page. You see here, it's not even a stateful widget anymore because I don't need to make it a stateful widget. I'm only calling my repository and including the HTTP page wrapper widget, giving it the type of the data it's going to contain so that it gets here correctly with the snapshot. I'm giving it the data request that retrieves the articles from the article repository. And I'm also passing the forced refresh flag, so it gets passed through when the user pulls to refresh. I'm also using it in the article page, like so. I'm using the different get article function that gets its ID when the article page is pushed into the navigator. And I'm using it with author articles page that also uses the get articles, but passes the username as a parameter to the request. Now let's take a look at how we created our offline banner, the one you see when you turn off the internet connection. This one. It's basically here inside the HTTP page wrapper, and it simply gets the same get data with a forced refresh true, so it forces a refresh when it's tapped. And here I'm using the selector widget of the provider package. You might know the consumer widget, which allows you to listen to any changes that happen in the provider. However, this one gets rebuilt only when a variable of this type is updated inside this change notifier provider. So here I'm using the is offline, selecting it here and using it. If it's true, then the banner appears with an on-tap parameter that refreshes the data. And if it's not offline, then don't show it. So it simply listens to this value. So when I turn on the internet, if you remember here, I'm resetting it to the responses offline flag every time I'm refreshing. So I refresh and it goes away. And that's it. You can now implement an API integration in your Flutter application with caching using local storage like we did. So let's wrap up by taking a quick look at the app architecture. We have three main layers: data, domain, and presentation. In our data layer, we have our data sources, which are local storage and remote API for caching and HTTP service. And we implemented those data sources using the service locator pattern and the getIt package. And we have our models with JSON serialization that converts the raw data that comes from the data sources into data that we can use in our repository. And we have our abstractions in the data layer, like the abstract service classes and the abstract article repository. Now, in our domain layer, we have the repository implementation, which in our case is the HTTP article repository. And it's at the same time a change notifier that belongs to the presentation layer that notifies the UI to change, making the UI and change notifiers part of the presentation layer. And that's it. Thank you very much for watching this. Don't forget that you can view the code of the application we went over using this repo link. Thank you very much for watching and see you in the next one.
That was amazing talk by Roa there.
Yeah.
I think we're waiting for a few more of our organizers to join. I think Sumith's still just wrapping up the second track, so we'll keep things going here. Do we have a Jen?
Yeah, Jen.
Jen has her mic off and her camera off, so there we are. There's a Jen.
I'm here. Okay, we're just gonna wait for Sumith to finish.
It looks like track 2 is just finishing up at the moment.
Yeah, I think they're finishing like a minute or something.
Less than a minute, I think, left on that one.
Yeah.
How amazing has the last 2 days been? Oh, tiring as well.
I think this was a very good Flutter weekend, definitely.
Yeah.
Indeed. How have the workshops been going? I haven't been involved in those because we just had a long day.
They went well, I think. There were I think cases where we need to redo them or reschedule some of them for different reasons. But in general, I think it went well. Right, Rulika? on both
Yeah,
tracks.
definitely. Some workshop has a
Yeah.
really good crowd as well, and people are asking questions and they are learning a lot from that.
Good.
That's good.
Yeah, it is really good.
It's more about the engagement, right? It's really nice to have people engaged. They're not just sitting there, just not really absorbing it. They're asking questions. They're engaging. That's what you want to see.
Yeah.
Yeah, definitely. Okay, let's just see. The last workshop actually is still ongoing, but that's fine. It's going well there. It's a funny thing. We had we had some intruders. I mean, the rest of the workshops today was good, was okay. This one was okay. It's okay as well. But we had two intruders.
We are so
There were people
popular with
dancing. So yeah, that was fun. But of course, I had to boot them out.
Let's see how what's going on over there. Bear with me, everyone.
So what do you think about our Flutter Festival London from last two, like yesterday and today? How was your experience, Simon?
My experience. I mean, I'm an organizer. I mean, I've been rushing around, sorting everything out. It's been a busy experience.
We've all been very busy.
Yeah.
And I think I'm really happy that
He's just wrapping up at the moment.
Yeah, I can hear it. Yeah, that's good.
So, let's just hang on.
went through the topics they wanted to cover. So we are back on track 1. Yeah, so people who are here, I think thank you for joining today. It was a pleasure moderating the channel, and I'll actually see you guys on.
Yeah, that's him wrapping up. So, I think it's been a good couple of days. I think we've learned a lot, and hopefully there'll be next time and it'll be better as well.
Yeah, I was going to say this is actually the first time that Google Developer Group London and Flutter London work together. I think it's been a good experience. I hope for everyone. So yeah, we definitely should look into working more together for Flutter events in the future.
You're on mute, Simon.
That was Smith. It's just he's going to join us.
Okay, he's going to join us. Perfect. Are we also broadcasting this in track 2?
No, we decided to close off track 2 and just direct everyone here because it's a lot easier when you're trying to talk to everyone in one place. I see Roa's in the chat. Hey, Roa, thank you very much for your talk. That was awesome.
Yeah, that was good. Yeah, I was watching that one.
Hey, there he is.
Amazing content today, and a lot of them.
Yeah, we're all here. We're all here now. So yeah, I think that's went really well. We're going to, so me and Smith were talking throughout today. There was one talk we couldn't stream because it was 4K and it was buffering too much. It just didn't want to work. So we're gonna go ahead. Me and Majid from Flutter Vikings, we did a script that sort of brings things together, so we can upload all of the videos after this, so everyone can experience them. And we'll look at the volume levels and any of the problems that you experienced today, and they'll be fixed as part of our video upload. So if you miss something, you'll be able to go see it in 100% goodness.
That's great.
I think that's the fun of being live. Yeah, so definitely we can go behind the scenes now to clean up some stuff that we did this morning. It was a long marathon, 6 hours.
6 hours.
So
well, it was longer yesterday. Remember, it was 8 hours.
And I really want to thank everyone, like the speakers, the sponsors, you guys, everyone, and also
yes, the speakers,
the viewers. Yeah,
we need to bring this up more. There we go. Thank you to our lovely sponsors: Code Magic, the Act Company, Invitays, Stream.io, and
Bitrise. Yeah, the App Company, Code Magic. It's really great. Thank you for the support.
Yeah, it's really been helpful to have all the support. It wouldn't have happened without our sponsors. So thank you so much.
All right, I think we should wrap up and let
Yeah.
everyone actually enjoy their Sunday, the rest of their Sunday. And also, it's Mothering Sunday in the UK today. So happy Mothering Sunday to all moms in the
Mother's
UK and
Day.
everywhere else where Mothering Sunday is being celebrated.
Yeah.
All right.
Okay.
I'll see you next time.
See you
Okay,
next
thank
time,
you very much.
guys. Bye bye.
Okay.
Bye.
Bye.